All right, what's up, everybody, and welcome to another episode of Model Monday Live, where we challenge you, the chat pros from around the world, using all different CAD systems to try to take a 2D drawing and turn it into a 3D model as quickly as possible. And this is kind of a special episode because we are right on the cusp of 69,420 subscribers. And so we'll get a live count up and running here once we get into the first challenge, and then we will see if we can make it to that goal. I'm going to stream a little bit of overtime today. I think it might be a little bit too lofty of a goal to get through 500 subscribers here in one single episode, but we'll see what we can do. I'm going to be asking all of you to please reach out to your friends and to your family and ask them to log into YouTube and hit subscribe here on the TooTallToby YouTube channel. This is our chance to actually make it to that goal, the ultimate meme number, 69,420. And today might be the day that we do it. If we could do it today on April 20th on 420, it would be amazing. And if I remember correctly, I think that there is a very special member of the audience whose birthday is today. So if you guys want to give a shout out to the CAD Queen and say happy birthday to the CAD Queen, I think it might be her birthday today. Otherwise, it's right around this area. So happy birthday to the CAD Queen, and a special day indeed. Also, a birthday here amongst my household. One of my roommates, it's her birthday as well. So we are going to be going out to dinner a little later, but we are seeing a smiley face from the CAD Queen here, which I'm going to consider confirmation. Happy birthday. Happy birthday. What a beautiful day, too. It was a beautiful weekend. We got to play soccer in the rain yesterday, which is always fun for the team that I coach. It's always a cool experience to play in these different weathers and kind of get them out there. And so we'll do a couple of quick shout outs here, and then we'll get to that very first challenge for all of you. But I just want to give some shout outs to all the amazing members of the chat. So welcome. Ricardo Jean says he says, hello. Hudson Blackburn says, I'm ready to compete. Let's go. Who's going to beat me? That's awesome, Hudson. Looking forward to seeing you today in the chat. What's up, FPV Kev? What's up, Khalil? Welcome. Guntis, welcome. Hello. Eric is here. What's up? Jim U. Kerberos is here. Welcome, my friend. Louis Mania says, hello, everyone. And RIIO Sophie is here. And Bill Black is here. Hello from not sunny but warm Florida. Nice. And Victor K is here. Says hello, Toby and chat. And Ricardo Jean says, I'm off today, but GG to the runners. Nice. Larry is here. What's up, Larry? And Juman is here. Says hello from Taiwan. Nice. Welcome. Thanks for joining us. And Serial Sal is here. Hello. And Ricardo Jean from Italy. And the CAD Queen is here. Says good afternoon. Feeling the Onshape love today. Nice. Of course, the CAD Queen usually uses Creo, so it's kind of cool to mix it up a little bit. And Albert is here. Hello, using Onshape. Two dive today. Says hello, all from the Boston area. Welcome. Thanks for joining us. And let's see here. The Vicky Chong is holding it down on moderation, and also in the chat here. Welcome. Tim is here. Says happy birthday. Happy birthday. And Benjamin Gombo is here. Welcome. Hello. This is my first time joining live. Nice. Welcome. Good luck today. Circuit Curiosity is here. Hello, everyone. WIADRO is here. Hello from London. Welcome. Matab is here. 8 family subs done. Nice. Yeah, we'll get the sub count up here in just a moment. I just want to get that first drawing posted for all of you first. And nice and easy. Nice. All right, good. And Krish is here. Can you make tutorials on SolidWorks simulation? We'll see if we can get there eventually, Krish. We'll see how things go. Mostly what we're doing here is CAD modeling, best practices, but we'll see what we can do. And Tobias says he might use plasticity, otherwise SolidWorks. Nice. And Maz is here. Creo. Is Creo good for a long term? Yeah, all the CAD systems are good. It's good to learn one. It's really good if you can learn two. I remember one of our instructors, I think it was Michael, said it's really good if you can learn two. He always tries to get his students to learn 2 CAD systems because then you start seeing the similarities, and that makes it really easy to learn other ones. So that might be kind of a good if you're looking for advice. It wouldn't be so much about which one particularly to get, but maybe try to learn 2 different CAD systems and look for those similarities. And once you learn those similarities, you'll kind of be able to pick up anything. All right, let's get into it here today. Today we are going to be doing some Model Monday live challenges for all of you out there in the chat. We're going to show you a 2D drawing, and you are going to attempt to model it in your CAD system and come up with the correct mass and kind of prove if you're the fastest amongst the chat. So We're going to be doing some live solves with TooTallToby. We're going to hang out with the best chat ever. And of course, we're going to try to get our sub count up. And of course, I couldn't do all of the things that we do here at TooTallToby without the amazing TooTallToby community. So thank you to all the subscribers, all the super thankers, all the joiners, the likers, the tutorial makers, the super chatters, all the value for value folks, the Practice Models Premium subscribers, all the students, all the sharers, all the commentors, and of course, the Discord crew. Thank you all so much for being a member of the TooTallToby community. And don't forget to hit the like button, subscribe, and share and reshare. Take a screen capture of what we're doing. Spread the word out there to your entire social media network. Even if that social media network is just a chat group with you and your aunt and your uncle, who knows? Maybe they're into 3D CAD and you never knew it before. So this will be your chance to let them know and get them to subscribe. Let your coworkers know as well. We're really going to be pushing on this idea of sharing and resharing throughout the live stream today as we make our way to 420 subscribers on YouTube. All right, let's get into it here. Oh, and Victor K coming in with some meme chat as well. 420 for the meme super chat. Thank you, my friend. Very much appreciated. Very, very much appreciated. That is awesome. Thank you, thank you, thank you. All right, here we go. And so what we can do here is today we're going to show you a 2D drawing, and you guys are going to take that 2D drawing. Usually what our runners do is they grab a screen capture, and you're going to try and turn it into a 3D model. You're going to calculate the mass, and then you're going to type that mass directly in the YouTube chat. And then in the second half of the first hour today, we're going to do the same thing, but we're going to enter the answer directly on the TooTallToby app at TooTallToby.com. And then after that, we're just going to kind of have a free-for-all. I'm just going to go through and start modeling stuff and doing tutorials, and I'll model it in SolidWorks and in Onshape, and we'll just make a bunch of tutorials about how to model some of the other challenges from the library. So in order to get the mass correct, you have to have the correct material density, and the correct material densities are listed here. You can see the material specification for all of the TooTallToby CAD speed modeling challenges. So if you're brand new to the show, take a moment, grab a screen capture of these material densities. These are also listed in the drawing in the title block, so you'll have another opportunity to see these, but just kind of make sure that they're ready, and that's going to give you a chance to jump out ahead of the crowd. And you can also visit us at TooTallToby.com/materials to see some other good tools for quickly calculating the mass based on these material densities. All right, basic rules are you can use any 3D CAD package. Make sure you answer in the specified precision, and the first correct answer in the chat wins. And what do you win? You win a point on our coveted Model Monday Live leaderboard. Last year, the first place winners had 19 points, so it's really anybody's game still, but this is where we can see kind of what people are doing and what types of points have been earned so far this year. You can visit us at TooTallToby.com, and you can see this leaderboard update live. And the advanced rules are this is meant to be fun and good-spirited. Occasionally, I'll make some mistakes, and the Ivan exploit is permitted. So let's take a look here at this first challenge. And as we get into this first challenge here, I just want to warn you guys, this one is a little bit tricky. I think you guys are going to like this one. It's a fun one to kick things off here for this April 20th, this 420 challenge, but it's a little bit tricky. You know, watch the dimensions. Everything you need is there, but it is kind of a cool one. So let's get into it here. As soon as I show the full print, you guys are going to be able to start modeling. So here we go in 3, 2, 1, go. And so the question here is, what is the mass of this part in 0.xxx pounds? This one is in inches and pounds. So 0.xxx pounds, what is the mass of this completed model? So you can see here that the material is ABS. It's listed down in the title block. It's 1020 kilograms per cubic meter. And you can also see here that the challenge, actually this is not a tier 1 challenge. I guess technically, actually, it could be. I'll leave it at tier 1, right? You could probably do this whole thing as one sketch and one extrusion, right? So that would make it a tier 1 challenge. So I guess we will leave it as a tier 1. You guys can kind of figure it out. You could definitely brute force your way through and do this all in one single sketch and one single feature. But what this is it's a 3D printed part that you would use to support a wood shelf, 1x3 wood shelf support. And what you can see here is that the challenge here is to try to calculate the mass of this part using the hex information that's in the view in the upper right. That's kind of where it gets a little bit tricky. The dimensioning to those hexes is a little bit tricky. Okay, I'll just kind of leave it at that. And everything you need to fully define this geometry and to turn this thing into a 3D model with the correct mass is available here on this print. But who can figure it out the fastest? And Serial Sal comes in with the first answer, 0.420 pounds. I'm not going to say if that's correct or not. We're not going to tell you whether or not it's correct until we get to the halfway point of the first hour here. While you guys are doing that, I'm going to try and get the live counter for our subs up. Jinky Bells is here in the chat. Says, yo, what's up? Welcome. Welcome. We are on our way to 69,420 subscribers. We're going to see if we can get there today. It's a little bit ambitious. I don't know if we're going to actually make it there today, but we can definitely try, right? That's what it's all about. All right, let's bring up a live counter here. Put this over here. All right. Some good CAD modeling tunes here. We like this. All right, guys. Hopefully that's enough time for you to grab a screen capture. Start modeling this thing up. We're going to see if we can add this in as a source here. Oh, I actually have a sub count live window here from the past. Doubt it's the same. Doubt it's the same. We'll just crop this down a little bit. And we'll keep an eye on this as we proceed through the live stream. Whoops. We could probably just do it like this, right? Just drop it up there. Oh, we're going the wrong direction, guys. Not a good start. All right, send it out. Send it out to all your friends and family, and we're going to see if we can get that number up to the ultimate meme number by the end of the episode. Good start. Good start. There we go. That's the right direction. Maybe somebody just misclicked. It was a test of the live feed. This is a cool model. I had a lot of fun doing this model, a lot of fun testing this model. This is one of these things where you could print this out and this could become your own riser shelf. You could put some 1x3 down here, put 2 of them down here, and then put 1 of them up here, 1 inch by 3 inch, which of course in the United States, we measure that at 3/4 of an inch by 1.5 inches. Or by 2.5 inches. So this one here, this would be for your 1x3 up in that top chamber. And then, you got yourself a nice little riser area. You could put some tools up there, some paints or things like that. Still small enough that it'll print if you have a smaller print bed. If you have like the 150 by 150 print bed, you could still 3D print this. So kind of a cool shape. I saw this on one of the, I don't know where I saw it, one of the maker websites. Somebody had made something similar to this, but Tim says, this is interesting for a tier 1. Yeah, I mean, it's complexity, not difficulty, right? So complexity-wise, you could do this all in one sketch. I mean, realistically, you'd probably do it in 4 or 5 different features. At least I would. I would definitely break it up. I would, well, you know what? Instead of telling you how I would do it, why don't I just do this? Let's just do it, right? We'll do it, as they say on the internets, we'll do it live. We'll do it live. Let's just do it live. I'll show you how I would do this in Onshape. 6 to 420. I'm going to make this a public document too, okay? I know I'm on the other screen. Wood shelf support. Okay, here we go. I started naming it before I brought this up. So for me, what I would do here is I would anytime I have a shape like this, I call it discretizing the model. So what that means is I look at the challenge and then I kind of break this up into different regions of the challenge. And what I mean by that is that like I consider this kind of the outside shape of the model. This shape here is like the outside shape of the model. And so I would probably start out with that shape, that kind of outside shape. And then I consider these pockets here the pockets for the wood planks. So that would be like the next thing that I would discretize, the next thing that I would cut into this thing. And then this area here would be like the pocket for the hex shape. So I would discretize that into its own shape as well. Now you could do these all as the same sketch, or you could do them as separate sketches. The advantage to doing them as separate sketches is that a lot of times that allows you to keep your sketches simple. And when sketches are simple, they're easier to troubleshoot. They're easier to work on later. The advantage to putting it all in the same sketch is that sometimes it's easier to create relationships between the two. So you have a couple of options there, but I think I would probably just straight discretize this into different shapes. So if I bring up my screen capture tool here, and let's put this over here. And then we put this over here, and I'm just doing that so that I've got a view of that drawing. What this might look like is in Onshape, I would come up here and I would say I want to use the correct unit system. So my workspace units here would be inches, and then my mass here would be in pounds. And then I would go front plane, begin a sketch, orient my view, and then I would come in here and I would create that first shape. So I would come up here to 5.75, and then I would come over here to 3 inches, and then come down with a little notch, and then come over like this, and then I would come down until I'm horizontal to the origin. And then the cool thing about Onshape is that it kind of like it gives like a preferential treatment to the automatic relationships that are being added before you add your dimension. So what I mean by that is when I drop in this end point here of this line and left click, then I can type in 1.125, enter, and it like pushes the top of the line up instead of dropping it down below. So it maintains that horizontal and that vertical. And so the same thing here, this line length is currently 6.078 inches, but when I left click and then let go of my mouse and type in 5.5, see, it automatically shortens that line and then gives me this kind of this final shape here. And I really like that about Onshape. That's a workflow that I've definitely gotten a lot of power, a lot of leverage out of. So now the final dimension on this sketch would just be the 60-degree dimension for kind of the outer shape. So if you're looking to get started with this thing, I think that's probably where I would get started. I think what I'll do is I'll finish this thing out at the end here, just to give the rest of you a chance to model, and then you could kind of watch the way that I model this thing. So I think I'll just leave this up on the screen, and then I'll finish this out at the end here before we move into the next section of today's live stream. And as always, guys, let me know if the music is ever too loud, too quiet, anything like that. You should hear a little bit of music in the back, but I'm not trying to go too crazy. Aman in the chat says, so crazy. I'm designing and finding your video therapeutic to watch at the same time. Thank you, my friend. That's very nice to hear. Tim says some feature scripts would fill this in quickly. Yeah, that's the way to go. Do it with a proper feature script. There's probably an opportunity here to maybe use like Vent or use another feature script. Victor will have to let us know in the chat if he was able to use Vent or if he was able to use another feature script there from Onshape. I was super clunky. Definitely wasn't the smoothest approach. Yeah, it can be that way with this one. I think this dimension here is really tricky. This 1.5 being to the outside of the hex instead of to the inside. I think it's a little bit easier when it's to the inside, but I don't know. It could be easier to the outside as well. It's easier in both spots. Matab said fill pattern. Yeah, fill pattern would be great for this one as well. We got Ad Nisas in the chat. He's the current winner of Model Mania. I think multi-time winner of Model Mania, another speed modeling contest that's out there. So welcome. Got a little bit of a celebrity in the chat with us. Welcome, welcome. Thanks for joining us. Great to see you in here. We're trying to get to 69,420, and we can't even break 68,900, but we're trying. 68,990. Yeah, maybe we should start small. We're trying to get to 68,990 subs throughout this live stream. We're gonna go for our marathon live stream here. Guys, welcome to the world of TooTallToby. If you guys haven't been here before, be sure to hit the like button. Be sure to share and reshare. Be sure to subscribe. And let people know what we're doing. You know, we would love to get some more subscribers in here. So if you're subscribed, that's great. But make sure that you reach out to some other people and ask them to subscribe as well. Just message your friends and family if you like what we're doing here. This is a great time to support, and it's totally free. All you have to do is have a YouTube account, and you can subscribe and help support and help us try to get to that magical meme number. Maztoon in the chat says, why is there no Creo user in the tournaments? The tournaments are open to everybody. So anybody with any CAD system can enter. All you got to do is qualify in order to get into the tournament. So the tournaments are open to everyone. And we're going to have our next summer open tournament a little bit later this summer. And that will be open to all CAD users. So Creo, FreeCAD, NX, all of the CAD systems. We better break the 69,420 mark. This is what we're going for, bro. That is what we're going for. All tournament models today. I don't know what we're gonna do. We're just gonna wing it. People could tell me in the chat what they want to see. I could do it based on that. Reach out, guys. Talk to your coworkers. Let them know what we're doing here as well. Let them know this is a pretty cool channel to learn and compete. And we'll give you guys some other stuff to compete to a little bit later. We'll just do, in the second half of the show today, we'll just do a bunch of competitions for everybody. Just make it fun for everybody. No points, just for fun, just for bragging rights. Okay, so join the party. Visit us at Practice Models Premium if you want to get more practice doing speed modeling. And you can also visit us at TooTallToby.com. Amon says, I've always loved NX, but I want to learn more Fusion for home use. This is a great time to learn Fusion. We're doing a Fusion tournament right now, actually. At TooTallToby.com, we've got the 300 club, and really we've got way more than 300 now, but you can definitely join the 300 club. You can try to complete over 300 models. We got a Creo user here, Mr. Vince, in the 300 club. Let's go, let's go. And that's an older screenshot. We probably have more Creo users in the 300 club these days. Let's see what we got. Look at Uncle Facepound up at the top of the list. Let's go. 321. That's what I like to see. Here we go. Mr. Vince up there. Let's go. Yeah, we got a lot of models. A lot of models in the library at TooTallToby.com. If you like doing this kind of 2D to 3D practice, visit us at TooTallToby.com. We've got the practice models library where you can attempt to create some of these models. We've got some featured models up top. You can get started for free. And then if you like this whole learn by doing methodology, well, like I said, we've got tons and tons of models that you can attempt to complete. And if you have friends or coworkers that are interested in that, you can send them a message and say, hey, you should subscribe to this guy's YouTube channel. And then they can learn more about this. And of course, we've been continuing the Power Move series on the YouTube channel. I think the most recent one we did was talking about flipping a derived sketch, but we got more recorded and ready to edit and post out there this week. So you'll see some more going out this week. If you are a SolidWorks user and you want to, up your SolidWorks game, you can take the challenge. You can try to go from 0 to hero using our SolidWorks training program at TooTallToby.com/training. The 0 to hero program starts you out with a totally free 30-minute quick start, and then you can take the SolidWorks 101 and the CSWP prep class. And within 1 month, you could go from being a novice to being a certified SolidWorks professional if you follow through those courses. So check it out. If you're in the world of SolidWorks, you're trying to get better at SolidWorks, those are some fantastic courses you can take, especially if you like my style of teaching. Gray is here in the chat. Gray RU says, hi all. Welcome, welcome. Thanks for joining us. And Dom Linder is here as well. Hello, got hung up in a meeting for the first round. Don't worry, we're going to be doing a lot of rounds today. All right, guys, and finally, in the world of tournaments, we are hosting an Autodesk exclusive tournament, the Autodesk Fusion Global Speed Modeling Tournament. A couple weeks ago on April 10th, we saw Junho and John Moriarty. It was John Moriarty who advanced, and we saw a friend of the show, Neil Zhu, advance through his April 10th match against Abiodun Samuel from Nigeria. And then last week, we got to see the Guitar God go against Matab, and we got to see Tristan Lusung go against Sadnan. And you guys can watch those videos or watch those highlights if you want to see how our runners did. But it was very cool. Very cool to see Matab in the tournament, who's a one-time tournament winner using SolidWorks, multi-time tournament competitor using SolidWorks, and now he's showing off his skills using Fusion as well. So really, really cool seeing a friend of the show here in this tournament as well. If you guys want to get the live stream links to those tournaments or to any of the stuff that we do here at TooTallToby.com, visit us at TooTallToby.com/calendar, and you can sign up for those and you can get the links. Get the links and then add those links to your calendar as well. All right, and in the second half of the show, we are going to use the Practice Models app. So when you go here to TooTallToby.com, up at the top of the library of practice models, we have these Practice Models app, the featured models, the featured Practice Models app. And in the second half of the show, we're going to have another Practice Models app show up here, or Practice Models Challenge show up here. Totally free for all users with a free account or with a paid account. So check that out. Yeah, I don't know if that's the same gray U, Lotos. I don't know if that's the same gray as Grapefruit, or if you signed up for a new account, if it's the same gray or not. I'll have to answer that mystery. I was kind of wondering that too. But guys, in order to earn the points, you have to sign up at TooTallToby.com for free, and then you can earn the points in the second half of the show as well, and kind of compete using the app. We post a lot of different practice models challenges on the TooTallToby library, on the practice models library. So make sure that you check that out. We got a lot of variety in there. It gives you, it's kind of like a gym for your CAD brains, a place you can go to practice and refine your CAD skills and just get faster and faster and faster, and really ultimately learn kind of what the software is going to do when you provide an input, and that's how you get faster. So definitely a great place to go and work on your CAD skills. TooTallToby.com/practice is the website. And be sure to sign up there if you want to participate in the second half of the show. Gray in the chat confirming that's me. That's me. All right, awesome. Thank you. Thank you, my friend. Welcome back. Great to see you in here again and loving the new logo. We not only post standalone parts on there, we also post assemblies. Towards the end of the month in February, we went through and posted all the models you need for this. So all the 2D drawings you need, including the clearances, to model up these parts, and then you can 3D print this thing out. It's just like a little ratcheting system. It just kind of like turns in one direction. It doesn't turn in the other direction, and it makes some clicky clanky noises as well. Of course, probably the most popular fidgety type tool that we have on there is the 3D printable hex bolt and hex nut. If you guys don't have one of these yet, be sure to check out the TooTallToby practice models library, and we do have these available for you to practice modeling, and then you can 3D print it. And what's fun about this one is that when you first print it out, there's often like a little bit of filament in the threads, so you have to cycle it 20 or 30 times, and then it starts to get very, very smooth, and it becomes a very addictive fidgeting toy. So definitely a cool one to check out. A lot of times 3D printing people or structural people will say that it's not right, it's not correct, it's you didn't print it in the right orientation, it's not going to be strong enough, it's going to snap off right here at the shaft. And while I agree with those things as far as a structural point of view, you can't argue with results. This thing is very fun to fidget with. If you print these out and give them to your friends and family, they will agree, and they will also be fidgeting with these. And when you do print those out and give them to your friends and family, be sure to tell them that they should visit the YouTube channel at TooTallToby and subscribe so we can continue to get that sub count up as we're going through today's live stream. All right, it looks like most people have finished that first challenge. So let's get into it here with the answer for that first challenge. And we will talk more about some of the other news as the live stream goes on. But as far as that first challenge goes, what we saw in that first challenge was kind of a cool part here, this kind of hex part here. And I was going through and I was solving it there in Onshape. There's always going to be more than one way to solve this thing. But for me, like I said, what I like to do is I like to discretize my models, meaning I would probably take this shape first and extrude it to that 0.75 to get kind of like the initial shape in place. And then what that does is it gives me some really easy geometry to work with when it comes to my secondary shapes. So for example, to create this shape here, this shape is going to be 2.5 by 0.75, and then this shape down here is going to be 5.5 by 0.75. Well, it's really easy for me to create those shapes and then lock those shapes into place relative to 5.0 relative to the other geometry when I've discretized that out, when I've made that geometry just a little bit easier to see, to work with, and not complicated, not too many entities. When you get too many entities in one sketch, that's when things tend to get a little bit dicey. So that's kind of what you want to avoid. You want to avoid having too many entities in that one sketch. So if you created something like this, then it would be very easy for you to take that shape and then do a remove, and we would make that remove through all. So that might be, this feature here might be called something like main shape. And then this feature here might be called something like pockets for boards, for the wooden planks, pockets for planks or pocket for boards, something like that. And then we could easily get in here and create this kind of final shape. And this one's just going to need, sketch relationships, dimensions and sketch relationships. So like this line here and this line here are going to be parallel to each other. This line here, and I thought it was Shift B for parallel. It's just lowercase b, lowercase b. And then the remaining lines are just going to have the relationship of 0.25. So even though it takes more features, this is definitely the way that I would model up something like this. It's not only going to help you as far as like getting your initial shape in place, but it's also going to help you as far as just kind of making it easier to rework this thing, and kind of having these discretized features makes it easy to link the features to like a variable table or something like that, just because they're just discretized. So this could be called like pocket for hex, pocket for the hex shape. So now we get into the hex shape, and this kind of comes down to each person's going to have their own style. Each person's going to have their own approach. For me, my approach whenever it comes to creating any type of a pattern is that I always end up making the pattern oversized. So imagine each of these other things that I create is going to be a hex in the pattern. I always end up creating it oversized, where it like overfills the pocket region that it needs to fill, and then I end up cutting away the excess geometry. And with Onshape, you could do that with like an intersect, or you could do it with a cut extrude if you create the outer perimeter of the cut extrude as well. Either way, you can cut that geometry away. That's how I personally always do it. There's always more than one way to do it. I see people in the chat are saying, yeah, you know, like I like to go oversized. Victor's case, I actually went way oversized. Yeah, so I mean, there's going to always be different ways to do it. So this is just one of potentially many different approaches, but here's how I do it. I would begin a sketch on this face up top, and then I would jump into the hex command. So we'll create a hex here, and this hex is going to be 6-sided, and it's going to be 1.5 for the size of the hex to the outside. And then what I'll do is I'll take this line and make those parallel. So add that parallel relationship again. And then I'll add in my dimension here. So dimension from this line to this line, that's going to be at 0.125. So that's kind of the overlap for the hex, and the dimension here, 0.125. So now look, that hex is nice and fully constrained. Now, a little bit of a pro trick here. If I know that I'm going to be creating a hex type of pattern, what I'll typically do is I'll get in here and I'll add in some additional lines. And these lines are going to be used for assisting with my pattern. So I could create a line here like this and create a line here like this, and we'll see how those are going to be used in just a moment. I might choose to make those lines Q as in for construction, but a lot of times that's what I'll do when I'm getting ready to create some type of a hex shape. So now that I've got that shape ready to go, I'll extrude it, but I'll extrude the shape here using the thin option. So I'm going to use the thin option here, and then I'll pick on that sketch 4. So that's going to get extruded thin. So what's the wall thickness? 0.125, and that wall thickness is going to the inside. And then what's the depth of this thing? Well, I could make this depth up to surface. So this could just go here for the depth here. I can make this up to surface or up to vertex. I'll make it up to surface here like so. And then I'm going to say that I want this to be a new part in my parts list. So down here, I've got this parts list, and you can see that because I chose new, see if I can get both these to show. Because I chose new here in this box, I'm ending up with a new part here in this parts list. And so this is kind of a good way if you know that you're going to overfill it and then need to cut it away. This could be a good way to do it. It also tends to make it pretty robust, because if like the pocket changes sizes and you need to overfill it more, the cut still works, at least in my experience most of the time. So hit the green check mark. There we go. That gives us that shape. And now that we've got that shape, now what we can do is we could call this something like hex shape 1. And now we can show the sketch from that hex shape 1, and then we can do a pattern. Now, there are other types of patterns we could use here, like a fill pattern or point pattern or something like that. But I'm just going to go with the regular linear pattern here. So the entities to pattern, I'm going to pick this guy here. And then for the direction of this pattern, I'm going to choose this line right here. So now you see that I'm creating that pattern. Now, the pattern's not going to be at 1.5, because that would be, you know, I'd have like a double wall thickness there. It's going to be 1.5 minus 0.125, so 1.375, 1 3/8. So that gives me the direction of that pattern. And then I just need to put in enough instances that this thing fills or overfills. So for example, I could put in 5 instances of this thing, and that way it kind of overfills. And so now that I've got that shape in place, what I would do here probably is I would just finish that pattern and then just make another pattern. So create another linear pattern here of all 5 of these. Okay, so we just grab all 5 of those bodies. And then for the direction, now we can go in this direction, the second direction from our layout sketch, which is going to the midpoint of the hex. So the second direction for that layout sketch. And then the distance, again, is going to be 1.375. And the cool thing about Onshape is that you can choose this option for centered, and that way it pushes it off in both directions. Now, again, this is kind of overfilled. I am kind of future-proofing this a little bit, because if that pocket ended up getting bigger, you know, I'm giving myself that flexibility reusability. So if I wanted to make like 3 or 4 different sizes, I could overfill this and accomplish it that way. There's more than one way to accomplish it, but this at least gives me play for a little bit of a larger pocket here. You know, maybe what I could say in my planning here is I could say, well, I might end up with a situation where I've got 3 boards across the bottom. So each one of the boards here is 2.5 inches. So maybe I want to account for having 3 boards across the bottom and 2 boards across the top. You know, so in this scenario, it looks like I'm pretty much accounting for that. So, you know, you want to think about it. You want to kind of future proof it and think about kind of what scenarios might come up. But this seems like a reasonable scenario. I might want to create a version that has 3 boards across the bottom. I might want to create a scenario where I've got 4 boards across the bottom. And so you want to think about that. And, you know, maybe I need 1 more in this direction to facilitate that. So maybe in my second pattern here, I would say I want this to actually go out to 4. Okay, as long as Onshape can handle it and you're not getting like an exorbitant rebuild time, it's probably fine to do it that way. And that way you could create, you know, multiple versions of the main shape, and you're still going to end up having a good, you know, good reliable result from that hex pattern. So once you've got that stuff in place, what I would probably do at this point is I would probably just choose to union this just to make it a little bit easier to do my cut. I mean, you could do it, I guess the other way you could do it would be to do it with like an intersect. That would certainly work as well, but we would want to do an intersect and not include this body. So, you know, maybe what I would do at this point then is I would just take everything other than this first body. So this first body here, or this first part in the list, this is like the main shape here. So if I rename that to like main shape body, now what I can do is I can take the rest of these. So pick the first one. Now I'm going to hold shift on my keyboard. I know I'm not showing my keyboard cam right now, but I'm going to hold shift on my keyboard, and I'm going to go all the way down to this bottom one. And then I'm going to right click, and then I'm going to choose union, Boolean, union. So that combines them all together into one single part. And now what I can do is I can take the sketch that I had originally used here, or I could even just pick in this region. This is the cool thing about Onshape, is that Onshape does a good job of like letting you just pick a region, but I could also just go to that earlier sketch that I created. So this is the pocket for hex, and this is the pocket for hex sketch. So I could take this sketch here, which is the pocket for the sketch that I used for the pocket for hex, and then I could do an extrude. So now you see I'm doing an extrude from that pocket. Now, just to make it clear what's happening there, if I just change this to a solid and then I choose that sketch from the pocket for hex, you can see here what that region is that I'm extruding. But instead of doing it as a solid, I'm going to do it as an intersect. I'm going to do this as an intersect here. And then for the intersect, I'm going to choose to merge with part 2. That's this part here. And then also I'm going to choose to merge with this. There's one extra little part that's hanging down here that didn't get included in that union. So let's see if I can merge it with both at the same time. Ooh, not going to let me merge with both. Well, I guess it doesn't matter, right? That part. No, this is what I want. Oh, I see what. No, I'm sorry. I misspoke. What's happening is what the intersect is doing is it's extruding out in this direction, and then it's taking the overlap of those 2 intersections and it's only keeping them. Well, when it does that, it's creating one extra part down here. This extra part down here is being created, but that's okay. That's expected. Yeah, it was a little bit strange because we started out here with just this one extra part, and now we're ending up with 3. But watch what happens here. So we take this sketch here, the sketch from the pocket for hex, we do extrude, okay, and then we're going to say this is going to be an intersect, so solid intersect. So we pick that sketch again. Okay, and now what's happening here is that we're able to take that sketch and we're able to say we want that to go through all. And anywhere that extrusion intersects with this other part, we want to end up only keeping what's overlapping and omitting everything that's not overlapping. So then we hit the green check mark there, and boom, there we go. There is our hex pattern filling in that shape. And in theory, at least in theory, if we were to now take this original main shape and maybe make a change to this original main shape. So let's say we change this from 5.5 to... Here, I'm going to take this dimension and change this dimension to a dimension from this side so that it just grows out the side. So we'll make that dimension there 2.5. And now if I take this 5.5 and then change that to like 7.5, in theory, the hex should update. Yeah, look, see it updated there. That's what we like. So if we take that 7.5 and then we change that back to 5.5. So that's really, I guess that would go up to 8, right? If we were adding 2.5 to it, it would go up to 8. and then that would give us enough room for 3 boards and give us enough room for 3 boards. This one's a static dimension. I should have made that off of that side as well, but you get the point that I'm going for here. The hex pattern updates automatically, and that's what we want. So yeah, exactly. Parametric final boss. Exactly. All right, so now we can merge these together. Right mouse button, Boolean, just like we did before. And then we can right click and we can say assign material. And the material in the title block is the ABS. So we go in here to TTT custom materials. We go to ABS here. It's got the material density of 1020 kilograms per cubic meter. And so now if we go in here to measure the mass of this thing, we're coming up with a mass of 0.248 pounds, 0.248 pounds. And let's see if we got it correct. Who got it correct here? Nice. S. Silver says, love from Arcadia. Nice. Thank you. From Arcadia University or from Arcadia. Is that the name of a city or a town? Let us know. S. Silver's in the chat. Let's go. Intersect for the win. Yeah, Tim says intersect for the win. Yeah, we just learned about that one last week thanks to Victor K. And Matab says, what a workflow. Learned a lot. Thank you, my friend. Thank you. And guys, don't forget, send the channel out to your friends and family. Hit the subscribe button. Thanks for the awesome birthday. Got to go. All right. Awesome. Have a great rest of your day. Kate, the CAD Queen, thank you for joining us here. And of course, we are going to have another challenge for everybody in the chat here in just a moment. But in the meantime, I wanted to just find out here who got that one correct. We always find out here who got this one correct. Let's bring the chat out and see who got this one correct. All right. So for this one, the correct answer is 0.248 pounds. That is, in fact, the correct answer. So we got it correct. Let's go. Serial Sal was the first one who came in with an answer. 0.4220. That's not correct, but I like that answer. Let's see here. 0.427 plus or minus 0.003. Matab, I think that works. Yeah, 0.428. Very nice. 2.248. Very nice. Congratulations, Matab, coming in there with the first answer that is correct. Well done, my friend. Let us know if you used Fusion or SolidWorks or something else for that one. And T. Luss, who's going to be, who was competing last week, he's going to be in the highlights this week, comes in with 0.248. Victor K, 0.248. Very nice. Getting that weird symbol next to some of these answers again. And Harass came in here, 0.253. Nicely done. A little bit high, but nicely done. And Adonis came in with 0.254, a little bit high. Maybe we'll see him revise his answer as we go down through. And 2Dive today, 0.296. It's a tricky model, right? And Aras came back in, 0.248. Nice. Guntis, 0.248. Very nice. And Art came in with the answer, 0.248. That is correct. This is not an easy model. B. Perry, possibly correct, but not to the correct precision, 0.248. Although I guess with that tolerance, 0.25 will work. 0.249, very nice, Kate. Albert coming in 0.248, very nice. Well done. Larry, 0.243, a little bit light, or 234, a little bit light. And TooTallToby came in 0.248. Khalil came in 0.248, very nice. Low Toast, 94 plus 4. We'll take it. I like it. Like the 94 plus 4. Very cool, guys. All right, awesome. So our winner of that first point is going to be Matab. Well done. He's on an absolute tear. He got through his matches last week, and now he's once again taking down some points here. Very nice, guys. Put a GG in the chat for Matab, earning the first point in today's CAD live stream challenge. And we are live streaming today, guys, and we are trying to get to 69,420 subscribers here before the end of the live stream. We are going to go a little bit long today, see how close we can get to that number. Oh, you're welcome. Thank you, 2Dive today. You are very welcome. My pleasure. Says thank you for the awesome tutorial. You're welcome. All right, listen, guys, we're going to get into the second half of the show now, the official show. And for this challenge, you're going to do this challenge over at TooTallToby.com. So if you haven't created an account yet, this is kind of your last chance. Create a free account at TooTallToby.com. And we're going to see a new challenge land there on the website in just a moment. And If you visit us at TooTallToby.com, what you'll see is that challenge will show up here under the practice models library in this brand new section, and that is where you're going to answer in order to get the point for this next challenge. But sometimes when everybody hits the website at the same time, it kind of slows down the website. So I'm going to show this one to you here live as well. Here we go. This next CAD challenge begins in, let me go to full screen here. 3, 2, 1, go. And so the question here is, what is the mass of this part in XXXX grams? We can see here this is kind of a mechanical part. It's called fork, and this is just a tier 4 part, not super difficult, nothing too tricky on this one, but a fun one. And a lot of times these are the parts that ultimately make your mechanisms work. A lot of times you need to maybe model up one of these and add it to your design. It's got kind of a cool square shape on the end of that shaft, which I think is kind of fun to model up. You can maybe try and do it with like a partial chamfer if your CAD system has that, or you could try to model it up manually. There's several ways you can model it up manually. But you can see here this part is called fork, and it is made from 6061 aluminum. And good luck. Good luck to everybody trying to solve this one. Great to see everybody here in the chat today trying to model this, and we'll model this one up as well. Maybe we'll model this one up in SolidWorks. Mix it up a little bit. Do some CAD in some different systems, right? All CAD systems are welcome here. FreeCAD, Fusion, Onshape, SolidWorks. All CAD systems welcome. All right, guys, I hope that was enough time to grab a screen capture. And of course, we will show you how to do this one in just a few moments on the website by visiting the website, TooTallToby.com. And we are in a race here to finish up our modeling here using our CAD system. And we're also in a race here to try to get to 69,420 subscribers. So if you know anybody who likes 3D CAD, be sure to send them a link. And I see Paul in the chat says, I started your CSWP class. It's great so far. Thank you, my friend. Glad to hear that it is helpful. And I love that it's working for you. Hudson says, where do we input our answer? You go here, TooTallToby.com. You say access full library. And then there's a brand new challenge right here at the top, 260405. Click here to practice. And then you can input your answer directly here in this bin. Click here to begin. Reveal drawing. Here it is. Look, there's the fork. You can answer right here, right in this bin. All right, so good luck. How many people have done it so far? Looks like one person has done it so far. See if we can get some more people in there. Tim says, I'm just trying to be proficient in one system. Yeah, nice, nice. Guys, we mentioned before the break that, of course, we've got Practice Models Premium. You can sign up for Practice Models Premium. One of the newer things that we've added to Practice Models Premium is the ability for you, the members of the TooTallToby audience and community, to create your own drawings. There's a lot of people out there that say, I've got a pretty good drawing you might like in your library. Well, you actually have the ability to do this now. You can create your own drawings, you can upload them, and if you're a user of the TooTallToby library, you can attempt to complete models created by other users in the community. So you can see here that as we scroll down, we've got this list of Toby created challenges, but then we've also got a list of challenges created by members of the TooTallToby community. And there's some really fun challenges here in this menu. So if you haven't had a chance to check it out yet, be sure to check it out. The user submitted challenges at TooTallToby.com. And if you are out there and you are a creator of drawings and you want to get some added to the library, just go in here to this menu, USCC, and you too can become a creator of drawings, get some fame here in the community. We've got Casca, we've got Matab, we got Uncle Facepound. They're the main people who have been submitting those, and we're always looking for more people to get in there and start making more of those challenges. So I want to, Paul says, I want to model a body kit for my car. Is there a way to bring a model of a car into SolidWorks and model off that. Yeah, I mean, ultimately the challenge you're talking about is the idea of going from scan data to 3D modeling data. Usually the problem is that scan data is like a loose mesh that's not watertight, and what you're looking for in SolidWorks is more like a B-rep that is watertight, doesn't have any gaps or holes or anything like that in it. One of the most common workflows that people do when they're coming from scan data into SolidWorks is they bring in the scan data and then they just kind of like draw around it. Like the scan data is coming in at 1-to-1. It's coming in as a 3D model. So it gives you enough information that you can model around. And then you just kind of model the parts that you're trying to retrofit to it. So for example, if I was working on an automobile and I had like a head unit in the front dash of my car and I wanted to design something like a cover plate for it or something like that, I might scan in the data and then design my cover plate around it. Now, sometimes you have to get a little bit more in detail and you have to take that scan data and actually turn it into surface geometry and ultimately turn it into solid geometry. And that gets a little bit deeper. To just bring in a scan into the world of SolidWorks or Onshape or any other 3D CAD system, it's usually pretty straightforward. The thing is, most of the time you want to think of that scan as like view only. You're not really going to be able to do much with it, but it is at 1-to-1 and it is in 3D. So it is still very valuable. Victor K says we should do a live stream sometime where I walk through how to work with scan data. Boom, let's book it. I'm in. 100% in. Yes, let's do it. And FPV Kev says, I have to go. Great show as always. Thank you, my friend. I know a lot of you have to leave right at 2 o'clock, and that's fine if you have to leave. Thank you so much for joining us today. The show is going to go a little bit longer today, and we're going to see if we can get to 69,420 subs before the end of the live stream. At the rate we're going, if I'm doing the math correctly, we're going to be live streaming until next Thursday before we get to that number. So we might end up calling it a little short. We might lower the goal a little bit. Maybe we'll just try and get to 69,000 subscribers. I like the fact that we're at 68,996. That's always fun too. Yes, very helpful. Yes, please have Victor on for scan data. Yeah, you got it for sure. For sure. Yep. I'll try and make some more scan videos, scan data videos as well. Guys, one last thing I just wanted to share with you is that we do have a new platform for educational users. If you're in the world of TooTallToby, you are in the 3D CAD community, the global 3D CAD community. We all interact with one another. We try to meet each other. Sometimes people even meet each other in person. You know somebody, you're in Europe and somebody else is in Europe, and you can actually meet them for a beer sometime at a pub, something like that. And it's awesome. It's a lot of fun. We have people who are submitting videos of themselves speed running these models. We've got a Discord, and all this stuff is really great for the idea of a global CAD community. But there are also some tools that maybe are a little bit more specific for educators, and those would be tools like setting up a classroom and setting up a leaderboard that's just for that classroom, and maybe a little bit less community sharing, a little bit more student data privacy and student protection, protection of who those students are, user obfuscation, things like that. So we've developed a brand new platform to help with that. It's called CADpractice.com, and we have these types of tools for educators, classroom management tools. You have the ability to assign challenges to your students. We utilize competency-based learning for the CAD skills that they're learning, and we've got a bunch of student data privacy tools built into that platform as well. So if you're ever interested in checking that out, you can check it out at CADpractice.com. CADpractice.com is the sponsor for this week's featured models, and so you can learn a little bit more about it here, and we are continuing to build out that website for STEM and CTE educators. If you're watching the show today and you happen to be a STEM or CTE educator, this might be a perfect solution for you. And one of the coolest things is that you do get a local leaderboard just for your class. So the students get to compete against one another, both at the total point level, but also at the individual challenge level. So you get to see who's the fastest in the class at completing certain models. And that creates for a lot of engagement with the students and kind of helps them continue to refine their CAD workflows as well. All right, guys, if you want to learn more about that, you can always email Vicky at TooTallToby.com, or like I said, you can visit us at CADpractice.com or visit us at the Practice Models website. They are the featured sponsor for this week's challenge. All right, let's get into the second challenge here. We're going to do this one as a live solve. I think I'm going to boot up SolidWorks here, and we're going to give this thing a try using SolidWorks. I know there's a lot of SolidWorks users out there, and I hope you will find this insightful. And of course, like I mentioned before, some of the models that we post here at TooTallToby.com are rather tricky. Like we saw that hex model earlier. I thought this one was pretty fun, pretty tricky. The geometric pencil holder. I thought this one was pretty tricky from last week. And of course, this one from the tournament. These are all really, really tricky models. But listen, sometimes, you don't have to get tricky to get the job done. Sometimes we just need a simple machined part to act as a link between two other parts to maybe change the direction of a force or to act as a connecting link between two forces. And that is what this fork is doing here today. So let's get into it here today with our live solve. It is Model Monday Live, and so we've got members of the audience who are attempting to solve this thing with us. We've got let's bring up our keyboard cam here so that you guys can see all the keyboard shortcuts that I'm using. Let's bring up SolidWorks as well. And you know what? Let's put the sub count in here too so that we can still see how close we're getting to 69,420. We're really on a roll here getting to this sub count. Oh, wow. Fresh coffee. Thank you. This is what we need here to speed model our way through this next challenge. A nice fresh cup of coffee. Shout out to Mesa Makes, Mr. Mesa, regular on the show, regularly watching with his class. Coffee just tastes better coming out of that coffee cup. Zachary says, just subbed and bumped the sub count up. Thank you, my friend. Thank you, thank you, thank you. That is what it's all about. All right. All right, listen, guys, let's get into it here with today's live solve. Of course, we are here on Model Monday Live, and we are going to solve a challenge from the Practice Models Library. If you like doing these 2D to 3D CAD challenges, be sure to check us out at TooTallToby.com/practice. We've got a library of over 300 of these 2D to 3D CAD challenges, and these challenges are sorted by the complexity level of the challenge, so tier 1, tier 3, tier 2, tier 3, tier 4, as well as being sorted by the type of challenge you're trying to do. A lot of times we see people who just got their first 3D printer and they want to learn how to create models that they can 3D print. Well, all these models that are tagged as 3D printable are optimized for 3D printing. A lot of them you can print without support. A lot of them are just like little functional parts, like this clip here for your wires under your desk. Sometimes it's easier just to draw it up and 3D print it than it is to go out to the store and buy one of those. So, and the nice thing also is that when you learn how to design for 3D printing, you get to design the parts to be the perfect shape for what it is that you're trying to accomplish. And that's one of my favorite things about 3D printing is like adding in those little custom Toby features. So we're going to do this challenge today here at the top of the library, 26-04-05. This is available. There's a lot of models that are available for free. And then if you really like this method of kind of learning by doing, you can unlock the entire library with a Practice Models Premium subscription. Let me just move SolidWorks over here a bit. We are going to solve this in SolidWorks. And let me just make the chat a little bit smaller. You guys are going to see people over in the chat commenting as we do this live solve, because we are live solving during Model Monday Live. Here we go. My name is Toby, and I am from the United States. I'm going to be using SolidWorks here today. Wow, 11 people already solved this. Going to be using SolidWorks today, and we're going to reveal this drawing in 3, 2, 1, go. And so the question here is, what is the mass of this part in XXX grams? And we're going to enter that mass in down here. And before I start doing any kind of 3D modeling, I always prefer to come up with a game plan and then kind of follow through that game plan as I go through and do the modeling. So in the case of this model here, I'm looking at this model and I'm thinking to myself, all right, it looks like this circle over here is almost acting as like the anchor. It looks like there's a lot of dimensions that are coming off of that anchor, like the center of these holes over here is coming off of that anchor. And it looks like just a lot of dimensions seem to be coming off that anchor. This 20 here is coming off that anchor. Then of course the 45 is coming off of that. And I know that that end shape is a circular shape, but the rest of this is pretty blocky. So I think what I'm going to do is I'm going to make my first sketch look something like this. I'm going to come off here with a center, a line going up through the middle, and then I'm going to create an arc here that goes all the way out to the center of this circle here. That's at 167 dimension. And then I'm going to come back with that kind of fork shape down, back around to here, back over to here, over and down. And that's going to be my very first sketch. And I know that might look a little bit weird as a first sketch, but what's nice is that if I just draw in another line here, then I can use that first sketch as a revolve, and I can take that first sketch and revolve it into this circular shape here. So I think that's going to be my first sketch. And then once I have that sketch in place, then I think I'm going to be ready to create this this sketch here for the 80 for these two circles that are extruding up through. Now, I'm kind of tempted to just create that sketch here at the middle and then extrude it out 80 midplane or extrude it over 40 midplane because then it's just going to be easier to hold the customer's design intent. So we'll see what happens there. And then once we get to that chamfer, you know, I would love to make that chamfer with like a partial chamfer. The problem is it's kind of dimensioned weird. It's dimensioned so that it fits into a 36 millimeter square. So I'm not really sure what that chamfer is going to end up being. I know that this is at 45 degrees, so I'll probably just draw that triangle from the end and then just mirror it twice, and then I'll be done with that model. I think because this model is symmetric, I'll probably model half of it and then mirror it at the end, and then we'll see if we can come up with the correct answer. We're going to type in the correct answer down here. If we get it right, we'll be awarded a point. If we get it wrong, we'll get a warning saying this is incorrect. You got to keep modeling. This is one of the fun things about the TooTallToby library is you kind of find out right away if you got it right or not. So I'm going to say open in a new window. I know we took about 2 minutes and 20 seconds to come up with that game plan, but I think it's always good to come up with a game plan before you get started. And if you agree, be sure to hit the like button on this video. So I'm going to move this over here, and I'm going to come over here into SolidWorks, and let's make sure we can see SolidWorks here. And here we go. This part is in millimeters. So I'm going to say new part, use my millimeters template. I'm going to follow my game plan now. So front plane. On the front plane here, I'm going to begin a new sketch, and then I'm going to S key, create a line, left click, come over here like so. Just going to kind of come over. I'm not really sure how far over this line it's going to go, so I'll just come over. I guess I could come over to, I may as well just come over to 167 since I'm not really sure how long that line's going to be. And then I'm going to hit escape, and then I'm going to come back to my starting point here, and I'm going to come up to a height of 30/2. And then I'm going to come over in this direction, 20, and then I'm going to come up kind of an unknown amount. Then I'm going to come over in this direction, and this is going to go over to, I mean, really at this point, I could probably bring this one over to 45 to act as the depth of that cut extrude, and we'll see how we can use that a little bit later. And then I'll come over here, kind of an unknown distance, and then I'll hit escape, and then I'll come up to the kind of outer shape here for that arc and come over, come away, come back, touch the endpoint, and come down like so. And then I'll come down like so, and then I'll do the same thing with the inner shape for that arc. So come over here, come back, touch the endpoint, come down like so, and this one's going to come all the way down to the middle. And now we just need to add in some relationships, and this is where it's helpful to kind of practice, and learn what exactly you need from these different relationships. So, for example, this point needs to be coincident to this line. This point needs to be coincident to this line. We could choose to either make these two concentric, or we could do that with the arc dimensions. I think we'll just make these two concentric. So we'll make these two concentric here, and then we'll go in and start adding in our arc dimensions. So this arc here is going to have a radius of 36 for the, oh, sorry, that's the inner one. This one is going to have a radius of 18, and then the outer one is going to have the radius of 36. Sketch is a little tangled up right now, but I think this should untangle it. There we go. And then what we can do is we can add in a dimension here for the width of this thing. Now, sometimes when I know that I'm going to mirror the model later on, what I'll do is I'll add in a construction line, and then I'll just make those dimensions doubled across that construction line. So instead of having this dimension 15, 30/2, I'll cross over that construction line, and I'll make that dimension 30. Instead of having this dimension here be whatever it is, 36/2, I'll just cross over that center line and make that 36. So you can see here how I'm getting that doubled dimension to that location. Get that doubled dimension to that location. Okay, this end point here, or this line here, is going to be vertical to my end point of 167. And then the only thing that's left to do here is just define the location of the center of this arc. This is a little trick that we do a lot in SolidWorks. Even if we end up having a lot of experience in 3D CAD, if you end up with an underdefined sketch, just hit escape, grab a blue point, and start dragging it around. And a lot of times that'll help you figure out what is underdefined. So I'm going to create one final dimension here that goes from the origin to the center of this arc here, and that dimension is going to be 129. And there we go, all black, fully defined sketch. That's what we like to see. There was a question here, and the question came in, is there a Discord group? Yeah, you can go to TooTallToby.com, and up at the top of the page, there's a link to the Discord group. So here's TooTallToby.com, and then up here in resources, we have the link to the Discord group. So thank you for that question. I saw Victor K answered that as well. Thank you, Victor K. All right, so now we're almost ready to turn this into a 3D model. The only question here is, what are we going to do with this region here? And I think that the way to do this is just to close this off with a sketch. Even if you do end up using a circle on the end, you still want to close that off because you're going to want to use the rest of that region as kind of a closed extrusion. So I think I would probably do it the way that I just did it there. So now that we're going to create the next group of geometry, we're going to do S key, exit sketch, turn this into a revolve. And then what are we going to be revolving? We're going to be revolving just this region right here. So we're just going to take that one little region there and revolve it. And what are we going to revolve it about? Well, we already have one single construction line in the sketch, so SolidWorks kind of automatically picked up on that. But we're going to revolve it around that construction line there. And it's going to revolve to 360 degrees. And now we can go back and we can select that sketch again and maybe show it, and then choose to extrude that sketch. And now what are we going to extrude? We're going to extrude this region here. And how far are we going to extrude it? We're going to extrude it to 36 millimeters. And then we can just right click in the background and say mid plane, and then right click again. And now we can go to the top plane and begin a sketch, and we can draw in these circles here right on this geometry here. So we can make a circle here, which has a diameter of 60, and then S key extrude, and then that's going to come up to a height of 40. Okay, and now we can just do a couple of quick cut extrude. So again, we could go on the top plane. We could create a cut extrude here for this shape. So this one's going to have a diameter of 30, S key extrude, right click, reverse direction, right click through all, right click to finish. And then we could go back to the front plane, and we could use the front plane here and some of that geometry that we already have to get rid of this final shape here. So we could go from maybe like here to the silhouette edge, hit escape, and then grab this point and drag this down to this lower edge here. Now you have a nice fully defined sketch, and you can take that and S key extrude cut, and you can do right click through all, both right click. So that takes care of kind of the majority of the geometry. Now, the only thing that's really left to do here is just add in those little cuts on this side here. So pick this face, begin a sketch, S key, line, create a line here that comes over, down, up. Give that line a dimension. So maybe we could create a construction line here. Of course, we could do it from the top plane as well. We'll do another construction line here because we're going to mirror that geometry in a moment. So we'll give that line a dimension here, and that dimension is going to be 45 degrees. And then we could take that geometry and mirror it. So that was using the sketch mirror command. Now I have the sketch mirror command included in my context menu. So when I select multiple solid lines, I'll just show you this with a circle and a construction line here. When I create multiple solid lines and one construction line, I can just go right in here to this menu. If you want to get that functionality, just do the same thing I did here. And then when you go to this menu and mirror is not showing, right click and choose customize. And then you too can add that. And look at this, we're at 69,000 subscribers, guys. What a beautiful day it is. 69,000 on 420. That is a beautiful thing. 69,000 subscribers, exactly. 69,000 on 420. That's got to be meme worthy right there, right? Maybe if I move this down here. 69,000, 420. Let's go, let's go, let's go. That's what it's all about, baby. Very nice, very nice. So now that we know how that mirror is working, now what we can do is we can delete that extra example geometry. We can select this geometry here, and we can say mirror. And then once we mirror that geometry across, we could maybe do, really, we could do one more construction line here, right? And we could make this 45 as well. And then we could create our doubled dimension across that. I don't think I would do this. I think that's a little bit of overkill, but you could certainly do this and then create your doubled dimension so that you're using the actual customer numbers for your dimensions. Whoops, why did that go driven? Try that again. From here to here, cross over. Nope, that should be driving. Oh, I think because, yeah, actually I do know why that is. It's like kind of a newer thing that SolidWorks does, I think. Maybe it's not that. Maybe it's always been there. But it's basically when you create a linear dimension between a line and a line, if they happen to currently be parallel, then SolidWorks automatically adds a parallel like relationship, like it kind of embeds a parallel relationship in the distance dimension, and then that 45 degree dimension is technically over defining because it doesn't need to be 45 and have that linear dimension. In other words, when I went in here and I added that 45 and this one here has a 45, when I go in here to add a dimension and select this line and select this line, SolidWorks sees that they are currently parallel and then when we add that dimension, it kind of locks them together as parallel. So I don't have to worry about that angled line becoming not parallel in the future. So now when I go to add this dimension, it becomes over-defined, and then that dimension automatically becomes driven. So to look at this a different way, if I get rid of that 45, you'll notice that this line is blue, meaning it's under constrained, meaning I could just grab the endpoint and drag it around, and I could change the angle of that line. Well, this line here has got a dimension on it at 45 degrees driving. So now if I went to the dimension command and create a dimension from this line to this line, that construction line is going to become black because the two lines are currently parallel. And when I add in the driving linear dimension, it's going to also kind of like embed a parallel relationship in there. So it's a little bit nuanced, but it does happen in SolidWorks. And I think I've seen it happen in other CAD systems too. So it is kind of good to know, like, how come I can't add it? The question would be like, how come I can't add a driving linear dimension there in that circumstance? And the answer is because of the embedded angle dimension that it's kind of a little bit nuanced. But that's the answer. There you go. And now look, now that line is fully constrained. Yeah, I could see that. Yeah, that's kind of like a very interesting, sorry guys, I'm going to just go on like a really short tangent here, but that is kind of like an interesting scenario, right? If you had a line here at 35 and then a line here at 15, and then there was an angled line coming up like this, and then you had another angled line coming up like this. Let's say this is for construction. And then you took this line and you said that there was an angle here of 120, and then you took this line and you said that there was an angle here of 120. Okay, so that line is fully constrained and that makes sense. But now if you got rid of this dimension and then you tried to create a dimension between these two lines, would this dimension go over defined? Yes, it would. Why? Why would that dimension go over defined? Like how come I can't just define what the distance is between these two lines? I should be able to define that, right? I try to put a dimension on here and the dimension keeps going driven. And then I say, no, not driven, make that driving. Change that to from driven to drive. Oh, now the sketch is over defined. What? Why is the sketch over defined now? Yeah, that actually is weird. Yeah, it is weird. Yeah, this is always an issue in 21 also, Matab says. Yeah. Super intuitive. Yeah, exactly. So it is weird that happens because you would think that now you would be able to define that. But the reason why you can't define that is because when you add a linear dimension from this line to this, so now I got rid of the distance dimension and now I'm going to get rid of the angle dimension. When you add a linear dimension between these two, it kind of like imposes a driving parallel relationship because the CAD system doesn't want you later on to grab this point and drag it and then change the angle of that line. So it kind of like imposes a embedded parallel relationship. So if I get rid of the angle dimension, now I can make this thing fully defined with just the one dimension, even though I never defined the angle of this line because the driving linear dimension imposes a parallel relationship. Cool. Yeah, that one always catches me a little off guard. Sometimes the workaround that I'll do is instead of defining the dimension to the line. So let's say like we did have that scenario where this was 45 degrees driving. Sometimes what I'll do to get around that is instead of creating the dimension to the line, I'll just pick an endpoint and then I'll still pick the center line and then I'll go across because it still lets you make that one driving. So it's just like a little workaround if you're ever in this situation. Really is a 420 kind of day. Yeah. Yes, indeed. All right. So now we can do extrude. And in SolidWorks, if you ever go to do an extrude cut, let me change the color of this part. If you ever go to do an extrude cut and the end condition is currently set to blind. So you see here, this is currently set to blind. Then you can just single click on a vertex and the end condition will automatically change to up to vertex. So because I set that point up in kind of my original master sketch, it sets me up to really easily go in here and then S key, extrude cut, left click, right click, and I know that's going to be to the correct depth. And so now all that's left is just to pick this body, hold control, pick this plane here, let go of control, mirror. This is another one that I right click customized. Pick one, hold control, pick the other, let go of control. And then if mirror isn't there, then you can right click. So we go mirror and boom, mirror that thing across. And this is supposed to be made out of 6061. So we right click and we assign a material here, edit material, or we just make it 6061. And there we go. Let's take a look at our sensor here, Control Q, and we are coming up with a mass of 707,077 grams. And so now we go back into the app at TooTallToby.com and we attempt to type in that answer, 707.077 grams, and enter. And yes, we did it. We got it correct, and we got it correct on the first try. Let's go, let's go, let's go. And so that is it for that tutorial. I hope you guys enjoyed that SolidWorks tutorial. We got to learn some kind of cool stuff there. Even though it's a simple part, we still got to get in there and learn some kind of cool stuff about that over-defining dimension scenario. It's kind of an interesting scenario that can creep up. And we got the answer correct. And so if you guys enjoy these types of challenges, be sure to visit us at TooTallToby.com. We do have an entire library of these practice models. And the cool thing is that when we're doing this thing live here on Model Monday Live, we can actually keep track of who answered and when they answered. So you can see here that we've had a total, since I started doing that tutorial, or since I released this thing, we've had a total of 22 people successfully solve this thing. Now, we do have a top 100, which tracks the amount of time it took you from the time you clicked go until the time you answered. Well, you can see here that there's some people that are answering within, 1 second, 1.5 seconds. How are they answering so fast? Because I showed the drawing in the live stream, right? I showed the drawing in the live stream first. But we also have a tool here in the first 42 that shows us who answered it from the time it was revealed. So I revealed this thing at 1:50 p.m. and the first person to answer it was Matab. Wow, Matab again. What a speed demon today. So Matab got the point from earlier in the live stream, and it looks like he's going to collect this point as well. So 3 minutes and 18 seconds from the time I showed the print, Matab solved it using Fusion. 3 minutes and 18 seconds. What a speed demon. That is awesome. And close behind him, Dom, 3 minutes and 57 seconds using SolidWorks. And then H11R from Indonesia. I love seeing that in the top four, we have 4 different CAD systems here. H11R doing it in 4 minutes and 30 seconds. Wow. And Gray, what's up, Gray? Great to see you in here. Gray doing it from SolidWorks, 4 minutes and 32 seconds. T. Luss, saw him last week using Fusion, 6 minutes and 5 seconds. Kayvon, 638 using FreeCAD. Lotos from the Ukraine using Compass, 6 minutes, 54 seconds. And we've got Antapeli, 7 minutes and 15 seconds from the time it was released. And continuing down here from Sweden, we got Fighting Zeds. Yo, let's go. I wonder if that's Tobias using Plasticity, 12 minutes and 1 second. We got Albert here from the United States, Onshape, 12 minutes and 22 seconds. Jim U. Kerberos from Sweden, FreeCAD, 12 minutes. Nice to see the Swedes in here in force today. That's what's up. And we got Aras here from Indonesia using Inventor, 12 minutes and 59 seconds. We've got Undefined Explode in here using SolidWorks, 13 minutes and 7 seconds. Larry K from Czechia using FreeCAD, 13 minutes and 8 seconds. Kaska from Latvia, 14 minutes and 58 seconds. Serial Sal, good friend of the show, 15 minutes and 35 seconds. We got Inordili from Norway, SolidWorks, 16 minutes, 46 seconds. We got H. Blackburn in here, 27 minutes, 53 seconds. Full Metal Engineer using SolidWorks, 28 minutes and 1 second. We got Abdullah from Jordan using SolidWorks, 29 minutes and 23 seconds. And bringing up the caboose, we got TooTallToby, 29 minutes and 33 seconds from the time it was shown. Very nice, guys. Well done, well done. Good job, Matab. GG to Matab. Well done, well done. 3 minutes and 18 seconds. My goodness. Uncle Facepound says, taking the dog to the vet. Peace, everyone. Goodbye, my friend. Good luck at the vet. All right, guys. Here we go. Congratulations to everybody who finished that. It's not easy to finish these challenges, whether it's that one or whether it's the first one that we did. It is not easy to finish these challenges. So well done, well done. Look at this. Matab and Dom have posted a video of their speed run. So if you want to see this speed run, look at this SolidWorks speed run, 2 minutes and 4 seconds. Click in here to TooTallToby.com and you can just click here on the link and watch the video. Let's watch this video of his speed run. Let's see how he does it. Sounds like I'm talking in the background while he's speed running it. Let's see here, guys. Let me move this over a little. All right, here we go. Starts out with the circle. Interesting. 72 millimeter circle. I don't even think that's a dimension that's in the fork. Where's he getting that? Is that one of the circles? Where's he going with this? What is he doing here? The way Metab's brain works is very, very interesting. It's always interesting to see what he was in a polygon there. Okay, he got into a rectangle. All right, that's cool. Guess this is what he's going to use to cut off those notches. There we go. It just resolved to HD. Wow. Yo, I was not expecting that. Wow. Very cool. Metab, very, very cool. Oh, and he was using those circles to create the kind of fork shape. Yeah, but it's flat. It's flat on the top and the bottom. Very clean moves, especially considering he just saw it. This isn't like a model that's been in the library. It just got released, 30 minutes ago or whatever. Ah, but it's not right. It's flat. You missed the flats. Oh, he says, no, I'm not done yet. Wow. So it could have been even faster, huh? Look at this guy. He says, okay, no problem. No problem, Toby. I got you flats. Wow. Clean. Bro, that was pretty sweet. That was pretty darn sweet. Well done. Well done. Zoom. Yeah, that is cool. That is very cool. All right, let's see what Dom did. See how Dom did this one. All right, here we go. It's got some nice templates set up. I like that. Approved. It's got the clock on screen. I like that too. Approved. 36. Yep. That seems a little bit more. Not so clean. No, but good fix. Yeah, exactly. Very nice fix. Oh, that's cool. Put the 36 in there to get that kind of initial shape running around. Mirror across a plane. Okay, I like that. A lot of SolidWorks users might miss that one. I like that. Okay, dimensioning out to the end of that fork based on the... Let's see, what is this based on? I like Dom's precision here for these dimensions. Let's go. A little 6th place on millimeters. Okay, extruding. Going to do an extrude here using the contours. Like this. Extra precise and extra fast. Yes, exactly. See, this is how I would have done that shape. That was... Oh! Circular pattern. Okay. I like that. Yeah, and then make those two lines equal. That's a good way to get those to be 45 degrees as well. You could make those two lines, make those two lines equal. Very cool. Oh, and then cut it away. Yep, that's nice. That's really nice. Cut that away at the end. Now here's the question. What do you do with this extra circle? Can you do some kind of a delete face? Oh, he only put it out far enough that it wouldn't be in the way. Wow, that's good. That's really good. I like that. Very, very nice. Yep, that's good. Sign the material. Look at the mass, 707.077. Very nice. Wow, Dom. Sweet. Awesome, guys. Metab, Dom. Like. Let's go. Guys, if you like seeing these kinds of speed runs, check out the library at TooTallToby.com. We got a lot of cool speed runs, but I got to tell you, the fact that we just released this model and these guys are already posting speed run videos is just so cool. So cool to watch it there. I would have gone circle in the end, extrude, 8-sided hex, extrude, square, extrude, front plane, extrude, circle, extrude, top plane, extrude, etc. Yeah, that's kind of probably how I would have done it too. I mean, I know I did it a little different in my tutorial, but that's certainly a valid way of doing it too, and definitely will get you through it. Guys, we do regularly add to this library as well. In fact, I actually added one a little bit earlier today. So if you guys check out the library, if you sort, one thing you can do here that's kind of nice is you can do sort by and then sort in this direction, and then you can see the newer ones that are added. So we added a different version of one of the tournament parts, the hex, or sorry, not the hex, the pipe. It's called like the pipe filter. So that's kind of a cool one you guys could check out. Let's see here. Let's see if there are some models that I haven't had a chance to go through and do, and maybe we could do them together. And of course, if you guys in the chat have any requests for models, I'm happy to go through and do them as well. Figured I would just go through and kind of take a look and see if there's any cool ones that we could go through. This one's always fun. I mean, sheet metals are always fun. Let's give this one a try here. So I'm going to do this next one here. We're going to do, if anybody has to leave, it's all good. All good. Thank you guys so much for showing up. Don't forget to hit the like button. Don't forget to subscribe. Don't forget to send out the subscription link to anybody that you know. I'm not sure if at this rate we're going to make it to 420 at anytime soon. So I probably will stop the live stream in another half hour or so. But I figured I'd do a couple of models here before we do that. Materials guy says Dom's method was much closer to what I did, just a lot faster. Yeah, that was pretty cool. Pretty darn cool to watch. Guys, don't forget to hit the like button. Don't forget to hit the subscribe. And we are going to do another live solve here. Live solve in 3D CAD here at TooTallToby.com. If you're not familiar with TooTallToby.com, you can visit us. You can sign up for free, and you can access a library of these 2D to 3D CAD challenges. And then if you like this method of learning, kind of like learning by doing, then you can sign up and unlock the entire library. So we're going to do this one here, 26-02-07. And we're going to do this one using SolidWorks. We're going to do some SolidWorks stuff today. We'll do some Onshape stuff too here. So we're going to reveal this drawing and go. And so the question here is, what is the mass of this part in xxx.x grams? We're going to try and type it in down here, 420.7, and enter. And nope, that is not correct. And that's the cool thing about the website, is that if you enter in the wrong answer, then you are going to have to go through and you're going to have to keep solving, keep trying. You get to be kind of your own line of defense, your own first line of defense. So this is a sheet metal part, and you don't have to design it as sheet metal, but it's always good to learn how to design in sheet metal. And one of the main things that you want to be looking for is there a shape that I can draw that represents one or more of the bends of the sheet metal part? And so I think in the case of this part here, yes, there is. We could probably create this shape here as our first shape and then extrude that down as a sheet metal shape. Now, what gets tricky about sheet metal is that sometimes you run into scenarios like this where the dimension is to the outside of the material here, the inside of the material down here, this 40 dimension, and we don't have both outside and inside in our sketch, but that doesn't mean that we can't. It doesn't mean that we can't make that. We can always make the outside and inside dimensions from our sketch. So let's give this thing a try here. We're going to try to create that shape first. We're going to extrude it down the length of the part, and then we will kind of hollow out the inside of the part here, this shape here. It's kind of hollowed out shape, and then we'll add in that bend there along that top edge of the part. So I'm going to say open in a new window. This gives me the drawing here in a separate window that I can move to my second screen, and we're going to jump into SolidWorks. Let's see if we can solve this thing in under the average amount of time. And of course, if you guys want to play along with, you are welcome to look up this drawing and attempt to model this thing right along with me. We'll see who can model it the fastest. But I'm going to try and model this thing in SolidWorks, and we'll see how long it takes. So we're going to go in here to new. We're going to choose to create a new document here using our millimeters template. And we're going to try to create this shape here from the end of the part. This shape here from the end of the part. And that means that we're going to use some offset geometry to create that full shape. In other words, I'm going to go in here to the front plane, begin to sketch, orient my view, and I'm going to create this kind of line over and this line down like so. And then I'm going to hit escape, and I'm going to take that geometry and I'm going to mirror it. So take this geometry here and we'll mirror it. And then I'm going to take these lines here and I'm going to use the offset entities command to offset that geometry. Now, one thing that I really like about SolidWorks is that when you do that offset geometry, you can say you want that offset geometry to immediately become construction. You can also say that you want to cap ends. And learning how to use these tools, learning how to use the offset entities and learning how to use the cap ends and learning how to use the construction options, this will really save you a lot of time when you're working in sheet metal, because you can see here that you can cap the ends with arcs, but you can also cap the ends with lines. So if we do this offset here and we offset it to the wall thickness of the sheet metal, which is 4 millimeters, so offset that to 4 millimeters, enter. Now we set ourselves up with a shape that's going to be really easy to define. We can take this point here, hold control, pick the origin, let go of control, and we can make those horizontal. Let me bring up my keyboard cam here. So we can take this point here, hold control, take this point here, let go of control, make those horizontal. We can do S key dimension and create a dimension from the top plane to this line up top here, or from the origin to this line. That dimension is going to be 40. For the max width here, from this point to this point, that dimension is going to be 120. We've got an angle dimension. So again, we can click the top plane and then click on this line here and then put in that angle dimension of 45 degrees, and boom, that sketch is fully defined and ready to go for our sheet metal application. And that's the cool thing about using offset geometry, is that if the customer gives you some kind of like mix and match of inside to outside, you can just offset the whole thing and make that what the wall thickness of the sheet metal is, and that's really going to set you up for success. So if you like that tip, be sure to hit the like button, and let's now take this geometry and S key extrude. Oh, sorry, not S key extrude. Let's take this geometry and sheet metal base flange tab. Take that geometry and sheet metal base flange tab. We're going to go backwards with this one, and we're going to say that we want that wall thickness to be 4 millimeters, and we want the inside bend radius here to be 6 millimeters. So 4 millimeters, 6 millimeters, and then for the depth of this extrusion, we're going to go out to a depth of 200. Now, the options down here for like K factor, they're not really going to come into play on this challenge. Normally, I would have my K factor somewhere between 0.3 and 0.4. So leaving it there at 0.4 is fine, but it's not going to come into play for this application because we're not generating a flat pattern or measuring to a flat pattern. So 4 millimeters for the wall thickness, 6 millimeters for the depth, or for the default inside bend radius, and 200 millimeters for the depth. We hit the green check mark, and boom, there is our first sheet metal feature. Okay, just to make this look a little bit more like the actual part, I am going to assign the material of plain carbon steel, and that should also make it a little easier for us to see some of the preview colors that we see here in this model. Well, I'm trying anyway. It's kind of getting washed out a little bit here. Maybe I could change the color a little bit. Let's see here. Make it like this. There we go. So now I'm going to go to the... See, this is where this model gets a little bit tricky, right? Because that cut kind of wraps around the corners. So at first, what I'm tempted to do is I'm tempted to begin a sketch here on this surface and kind of like sketch that rectangle. But I think what might actually make more sense would be if I were to create that sketch here, looking in on this thing from the end. So either create a sketch that looks like this, or I could even create a sketch that just kind of comes down like this, comes up like this. You know, honestly, it could even just be a triangle, right? And we could just cut down the length of that sheet metal part. So maybe the better thing to do would be to create a sketch plane at 25 millimeters and then create this shape and then cut extrude that along the length of the sheet metal. So let's give that a try here. So we go here to our front plane. You put your mouse over the border of the plane. When you do that, your mouse is going to become a little 4-way arrow. And then what you can do is you can hold control and you can drag that. And then once you do that, hold control and drag, you can bring that out to a depth of 25 millimeters, enter. And now you've got a new sketch plane there. Pick that sketch plane, begin a sketch, orient your view. And you can create a sketch here that looks like I said, it could look like a triangle or like half a triangle. We could make this a mirror here. So we could have this look like a triangle here, like so. Take that line, make it for construction. I have my for construction mapped to Q. It's the same button it is in Onshape, so I map that to Q. Then I can select that geometry and mirror it across. And now I could take this line here and this edge here and make those perpendicular. Okay, and oh, I probably didn't actually want that relationship to the origin. That was a misclick there. Let's see, is it that one? Yeah, there we go. So I didn't want that to be on the origin because that's going to have a dimension, and the dimension is going to come from this edge down here to this line here. So that dimension is going to be 35 millimeters. And then for that top line, I don't really need a dimension to the top line. One thing that I'll do sometimes in SolidWorks is I'll put a dimension in here just so it remains fully defined, or really what I would do is probably put in a dimension from here, from the solid geometry of the part. So put in a dimension from here up to here, and then maybe make that like 30 millimeters. So if the top of the part moves up, the height of the rectangle moves up. And then you can right click on that dimension and you could say this dimension, let me hit escape here. You could say this dimension is not marked for drawing, not marked for drawing. And that means when you go into your drawings and you say insert model items, that dimension won't come in. It kind of shows up in a different color too. It shows up as this like purple color. Sometimes I'll also click on that dimension and put parentheses on it just to like let myself know. But yep, Albert, thank you. Thanks for joining us. Have fun on the rest of your beautiful Monday. So now that sketch is going to have a depth of up to 25 millimeters off of this end here. So I could take that sketch and I could do features, extrude cut, and then that's going to be offset from surface. And the surface it's going to be offset from is this surface here. And then the offset distance there is going to be 25 millimeters. 25 from that end as well. Enter, enter, and boom, there's our cut in our sheet metal part. So now that we've got that cut there in the sheet metal part, now we're ready to create this flange that is sticking up here. This flange is sticking up here. And it looks like that flange actually has kind of an offset to get to the location of that flange. So there's a couple of ways you could do this, but probably the easiest way to do it would be to just create a, let's see here. Looks like it's using the same width. Yeah, it's using the same width here as the tangent, the tangency from the arc. So probably the easiest way to do that geometry would be to just create a tab that's sticking out from here. So I could pick this face here, begin to sketch, orient my view, and then I could create a rectangle here that goes from this edge to this edge. Let me go here, view, display, tangent edges and phantom. So I'm creating an arc here that just goes to the exact width of this tangent to this tangent here. And then I'm coming over with that geometry and bringing that geometry out. And then that geometry is going to have a depth here of 41 millimeters, 41 millimeters. Now, what you'll notice here is that when I'm doing this, there's a little trick that you can do when you're sketching rectangles in SolidWorks. You could go from this corner to this point over here along this edge, and then without typing in a dimension here, you could type in that 41, enter, and then for this dimension here, you can just press enter again, and then sometimes that'll actually give you that as a coincident relationship. It actually didn't do it this time. I kind of lost that workflow. So let's try it again. Let's see if we can get it on the second try here. So from here to here, this one's going to be 41, enter. And then what if I tab off of that one and I just press enter? There we go. It still didn't give us that coincident. Rats. So you're still going to have to add that 41. The way I would probably do it is I would probably just do it like this. I would probably just draw the rectangle like this, and then jump into dimension and then add in that 41 as a secondary step. See, this is where you go through these workflows and you practice these workflows over and over again until, you keep getting faster and you keep refining those workflows, and then you can use them in the next model and in the next model and in the next model. So now that I've got that shape there, now I could go to sheet metal and I can go to tab. So we'll exit that sketch, and then we'll turn that into a sheet metal tab. So base flange tab, turn that into a tab, hit the green check mark. Now I can click on that edge, and then I can go into an edge flange command here. So here's edge flange to bring that up. And you'll see that when you're defining the edge flange location, the flange position here, one of the options is to use the inside flange position. And the inside flange position is tangent to the original geometry that was there. And that original geometry is that 41 that we dimensioned when we created that tab. So that way you get that tab to come up at exactly the right spot. See, learning about these flange positions when you're doing sheet metal is really key. It's going to allow you to quickly get in there and create the exact geometry that you want. Because, we've got the other one here, one material to the outside, flush, one material to the outside, entire bend to the outside. So if we know we want it to be this one here, flush, then what we could do is we could click Edit Flange Profile, and we can create the rest of the geometry for this flange. So the rest of that geometry for that flange is going to be something like taking this line here and making it for construction, sketching another line here that comes back to this endpoint, comes up and around, creating a sketch of a circle that lands right at the middle of this thing with a diameter of 20, and then defining the height to that circle from the floor to that circle at 135. So now you've got everything you need for that flange. You choose finish here on the sketch for the flange, and then look at that. Boom, you got the entire flange there all in one shot. So that's a great way to get in there and get that flange in place. And now the final feature that needs to be created here is just the holes. And there's a few different ways that we could create these holes. But I would probably use the rectangle trick here to get these holes into place, meaning I would create a sketch here of a rectangle or maybe a construction line. Maybe I would just do it with a construction line. So I would create a sketch of a construction line here that comes up to a height of 20, comes over here to a distance of 15, then comes over here to a distance of 145, and then I would have the perfect location for those circles. So pick this face, begin a sketch, orient our view, S key, construction line, single click, move our mouse up. This is going to come up to a height of 20, enter. Move over in this direction to a distance of 15, enter. Move over in this direction to a distance of 145, enter. Then S key, circle, and then we can drop in a circle here with a diameter of 13. And then we can drop in another circle here with a diameter of anything. And then we can just take these two and make them equal. Oops, take these two, and make them equal. And then S key, extrude, and that's going to go through all. Now we got those holes in there, and then we can take those holes and this plane and choose to mirror and enter, boom, mirror that across. And so now the final features on this thing are just those fillets, right? We got the 15 fillets on the outside and then the 8 fillets on the inside. And so with sheet metal, whenever you go to do fillets in sheet metal, you always want to go into corner here and do break corner, relief trim. And so that makes it easy to pick these corners. It makes it very easy to pick these corners, actually. So you just kind of get in the area of those corners and you can pick them. And whoops. Did that as a chamfer instead of a fillet. There we go. And then we'll just repeat that command, break corners, relief trim, and we'll make that 15 and enter. And then it would be like this one, this one, this one, and this one. And that should do it for that model. We'll do a control Q here to update everything. We'll look at our sensor. We're coming up with a mass here of 668.45. That makes me a little bit nervous. It makes me feel like maybe I forgot something because usually I don't have the mass come up as a weird number like that. 668.45. I guess I gave myself enough of a tolerance that maybe I did do that. Let's find out. So 668.45 and enter. That is incorrect. You're incorrect, sir. Let's see if we can get it correct here. I must have missed something. So how do we troubleshoot something like this? Well, first thing we do is we look at our material, plain carbon steel. That looks good. The next thing that we do is we look at the drawing, and we just kind of look over all the dimensions in the drawing. And so we'll start out here with our sheet metal definition. Let's just make sure we had our sheet metal going in the correct direction. That looks like it is going in the correct direction. It is 4 millimeters. Our bend radius is 6 millimeters, and we've got 120 max, and we've got 40 from the base up to there. So that all looks good. 135 up to that hole. 135, 20 millimeters for the hole. What's the distance from this edge to this edge? 37.37, and that's kind of what's being called out on that drawing as well. So those all look like they're pretty good. Let's see here. We've got our break corner on the inside with a radius of 8. Yes. We've got our break corner on the outside with a radius of 15. Yes. Good. Let's see here. Our holes have a diameter of 13. We made them equal and we mirrored them. So that's good. So that only really leaves this pocket here to be potentially incorrect. What did we do wrong with this pocket here? We did it at 25 from that end, which is correct. And we did it at 25 from this end with that plane, which is correct. And we did it at 35 up from the bottom there, which is correct. Guys, we did everything correct. What do we miss here? 668.45. Did we miss our... Does that flange look correct? Flange looks pretty correct. Oh, I know what we missed. I made the flange. See, look here. So to check this one, what I did was I picked this face and I hold control and I picked this face here. So with those two things selected, I can go down here into the status bar, and I can see that distance is 37 in the status bar. So why is it 37 instead of 41? Well, I made the tab 41, but then when I made the flange flush to the tab, and that dimension is to the inside, not to the outside. So I misinterpreted the drawing. So I made the dimension 41, which is good, but I should have made the flange position 1 material outside, and then that would have taken care of it. So there we go. Got to practice, practice, practice. Look out for these things. This is the kind of stuff the customers will give you, not because they're trying to trick you, but just because that's the critical dimension. Okay, they need to have enough room that this thing can slot into place on the next part that it fits into. It fits into a part like this. Okay, and there's a hole in that part that this needs to fit into. Well, it needs to have enough room to slot into that part. And so that's why the customer gives you these dimensions this way. So if I move that thing over, now this face is this distance, 41. The status bar is telling me down here 41. That's what we like to see. And so now let's see if we can get this one correct. So we rebuild, and 673.11, 673.11, and enter, and yes, let's go. That's what I'm talking about. We did it. We did it. Oh, and Otse is in the chat. What's up, my man? Welcome, welcome, welcome. We're trying to get to 69,420 subs during this live stream. It's very slow going. We're going to live stream for the rest of our lives. All right. And Hepatal says, go, Matab. Good luck in the tournament. Let's go. And Victor K says, start with crossing off dimensions. Yeah, that's all. I always give that advice to people, Victor K. I think you often give that advice as well. But, one thing that you can do is you can open this in a photo editor, whatever the drawing is. You could open it in a photo editor and then just use your marking tool in your photo editor and one by one go through the dimensions and just cross them off. Check it in your model and then cross it off here in the drawing. Check in your model, cross it off in the drawing, and eventually you'll find the dimension that is problematic, which in my case was that flange position. Now, the thing that's cool about doing these challenges is that you can run them more than once. You can kind of like optimize your workflow and run them more than once. And even without necessarily changing my workflow or cheating, I don't have any foresight necessarily of the project, but just kind of thinking to myself, okay, what sheet metal commands did I use a lot when I was in sketch mode? And what sheet metal commands did I use a lot when I was not in sketch mode? So when I'm in sketch mode, the obvious sheet metal command that I used was the base flange tab command. So what I could do is I could start a new model here and then go front plane, begin a sketch, and then just sketch some geometry, and then S key, and then I could right click and I could say customize. And from the customize menu here, what I could do is I can add the sheet metal commands for my S key menu. So here's my sheet metal commands, and the most common sheet metal command I'm going to use is going to be base flange tab coming right out of sketch mode. So I'll drop that down there at the bottom. And so now whenever I'm in sketch mode, I could S key base flange tab. That's going to help me be a little bit more efficient. Now, what about here at the feature level? Well, the most common S key menus I'm going to use are going to be like edge flange. Like I just want to pick on this edge here and I want to S key and pull an edge flange off. So I could right click here and say customize, and then I actually don't want this command. I don't want base flange tab. What I want here at the S key level for the feature level is I want the base flange tab command, or sorry, the edge flange command. So I could add in the edge flange command here, and maybe I could also add in like the sheet metal corners command to break the sharp corners. Let's see, which one is it? Here it is, break corner trim. Add that one in as well. Is there anything else that I really need there? I don't think there's much more that I need in the case of this model. And maybe, if these are the types of models I'm working on at the office, then it's going to be good to add those commands in. And so now what I could do is I could say, all right, let me try this thing again. I'll bet I could do this a little bit faster. So we're going to go in here to our TooTallToby practice models library. We're going to say try again. We're going to say reveal drawing. And go. And so, our game plan again is going to be to create a sketch here that comes up, over, and down. We're going to offset that sketch geometry, and then we're going to add in these dimensions, extrude it, add the cut here going through here. Then we'll have room for our flange. Since this flange is kind of offset here at 41, maybe we'll start by making a tab up top. Oh, that would have been base flange tab. Oh, that's probably why I had it there in that menu. So we'll add a tab up top there, and then we can add a flange here coming off of this, and then all we should have to do is add in those cuts, add in those holes, add in the fillets, and then we're good to go. So that is our game plan. So let's open this in a new window. Let's move this over here to our screen, and let's see if we can go through this thing a little faster, maybe even beat the average time there of 10 minutes and 40 some seconds, 10 minutes and 45 seconds. So let's see how we do here. Let's move this up. All right, you guys can sort of see it. So here we go. So we go new, and this is going to be a part in millimeters, and we're going to go here to front plane, begin to sketch, orient our view, S key. Maybe here what I'll do is I'll just start out by creating like a construction line for the floor, and then I'll create a line that comes up here like so, a line that comes over, and then a line that comes down at approximately 45. SolidWorks will often give you that 45 degrees. Take this line here, press Q, take all these lines here and mirror them. Actually, this one I don't want to be coincident to that line. It's the offset line that gets coincident. And then we'll take these entities here and we'll choose to offset those. So S key offset, and we're going to use the option for cap ends. We're going to use the option to make the offset geometry construction. We'll make that 4, enter, enter. And now we're ready to get in here and start adding in some dimensions. So the max width here is at 120. The height here from the base up to here is at height of 40. And then this point here is coincident to this line. So this is coincident here. And then finally, we've got our angle dimension here at 45 degrees. Now we can take that geometry and we can S key and jump right into sheet metal. And this is going to have a wall thickness of 4. Make sure it's going the correct direction. It's going to have a bend radius of 6. And this is going to go out to a depth here of 200 millimeters, and I'm going to reverse direction of that just to kind of match up one-to-one with the previous example. Now we're going to click on the front plane, hold control, left click and drag, let go of control, let go of the mouse. That's going to go out to a depth of 25. Now we can pick on that sketch plane, begin a new sketch. We can S key here, create a construction line. We can create a couple of solid lines here. And this solid line is going to come over and then kind of come down into a triangular shape. And we'll take that geometry and mirror it. It's good to have that mirror on that sketch shortcut. We'll take these two and make them perpendicular. We'll add a dimension that goes from here to here. And that dimension is going to be at 35. And then we could add like a do nothing dimension here because we want this thing to be able to withstand a rebuild. So we'll make that something like 30. And then we'll say that's going to be not marked for the drawing and it's going to have parentheses on it. And now we're going to take that geometry and extrude cut, and we're going to right click and say offset from surface. And the surface will be this surface down here. And then the offset distance will be 25. Okay, and now we're ready to create that base flange tab feature. So we'll begin a new sketch here on this face, and we will create just a rectangle that goes from here to here. And then we'll say that we want that rectangle to have a height here of 41, that dimension from the drawing, and that's going to use the base flange tab command. And now that we've got that in there, now we can just pick on this edge here, and then we can S key and jump right into edge flange and bring that up. But remember, for this one, we want to go one material thickness to the outside. So we choose this option here. That way that 41 dimension is the correct dimension from the end of the part. That was a step we missed last time. We say edit flange profile. We get normal to this sketch here, and we're going to take this line and press Q for construction. That's just a shortcut that I've got built in to change a line to construction. And we'll add in a couple of features here like so. This is going to have a diameter of 20. And then here, what we could do is we could do S key trim, and we could just trim out this excess here. We could even say keep trimmed entities as for construction. That way, we don't run the risk of running into an issue with that circle. It's kind of like an advanced move that you could do there with that circle geometry, so you don't actually trim it off and lose tangency on the other side. So then this is going to go up to 135. Okay, and that looks pretty good for the preview. Finish. Just do a quick kind of sanity check here. From this face to this face is 41. That's what we wanted, so that's good. This face here, begin a sketch, orient our view, S key, construction line from here up to 20, over to 15, over to 145, S key, circle. This one here has the diameter of 13. This one here has the diameter of anything. Pick this circle and this circle and make them equal. S key, extrude cut, right mouse button through all, right mouse button again to finish that feature. Take that feature, hold control, pick a plane, and you've got your mirror set up to automatically mirror that across. And now all that's left to do is S key, break corners. We're going to make this one a fillet with a radius of 8, and we'll get this guy, this guy, this guy, and this guy. And then we're going to repeat that last command. So you can just press enter to repeat the last command. This one's going to have a radius of 15, and it's going to be this guy, this guy, this guy, and this guy. And after we do all that, we can right click and say assign material, plain carbon steel, do a control Q, look at our sensor, and our sensor is showing 673.11. So let's take a look at the app here and see if we got it right. 673.11. Yes, that's what I'm talking about. 550. Yeah, average solve time 10 minutes 45. No. We're gonna blast through that average solve time. We're gonna do it in 5 minutes and 50 seconds, and that is what it's all about. So that is how you can use the TooTallToby app to kind of continue to refine your skills as you're going through and modeling. And if there are any models in the library you guys want to see me do, please feel free. I'm gonna keep live streaming here for a little bit longer. We are trying to get to 69,420 live subscribers here during the live stream, but we probably won't go for that long. Probably just go for another couple of models. But if there are any models you want to see me do, let me know. Otherwise, I'm just going to continue going through the library, and then I'll be able to extract some of these and use these for tutorials here on the site. I'll probably also kind of bounce back and forth between SolidWorks and Fusion and Onshape as well, doing some of these tutorials. Jern says, just joined finally. Welcome, my friend. Welcome. I know there were some people asking about how to do this one in Onshape, so maybe that's a good spot to jump over and do the shovel handle here in Onshape. I know there were some people asking about that one. I did post a tutorial of how to do that one in SolidWorks, but let's do this one in Onshape as well, and that way we'll have kind of a well-rounded tutorial set for that one. Guys, welcome to the channel. We are doing some live solves here. Great to see everybody here in the chat as well, talking to each other. All right. Take a sip of my delicious coffee. All right, let's give this thing a try here in Onshape. So welcome, everybody. We're going to do another live solve tutorial here. It is Model Monday Live. We are on a marathon live solve live stream here today. We're trying to get to 67,000 and some subscribers. 69,000. We already got to 67,000. We're trying to get to 69,420 subscribers. All right. And Dark Luna says, this is so much better than my lecture classes. For some reason, I'm hooked on CAD. That is awesome. Great to see you in here. Are there any parametric practice where you need to keep some variables and submit multiple answers based on different parameters? I mean, you should be doing that anyway. You should definitely be doing that anyway. I mean, we talked about that a little bit here with this one. Like that should just be kind of built into your workflow. I don't really need to test you on that because it's like it's just kind of like built into your workflow. You know, if you're learning how to play scales on a guitar, for example, I'm not gonna like test you on whether or not your guitar has been intonated properly. And so it's kind of the same thing here when you're doing 3D CAD. You should always be asking yourself, like, how is the model going to change? And you should be thinking about that when you are doing the design. So, for example, with this one, I did this one a little bit earlier in the live stream. This sketch here, the sketch that I created here, was created in a way that it could facilitate a board that is 2.5 inches and 0.75 inches high. But what we could do with this one is we could say, you know what, I can cut a board to any shape that I want. So instead, I'm just going to make sure that I've got 0.25 wall thickness over here on this side. And same thing on the bottom. I could just say I can cut this board to any size I want. So I'm just going to make sure I've got 0.25 wall thickness over here on this side. Now, what this does for us is, because when we got to our hex shape here, we created the hex shape with a, oops, sorry, let me move this onto screen a little bit more here so you can see the tree. I'm going to hide my keyboard cam just for a minute. So the question I'm answering here came in the chat here from Blue. I'll just call him Blue here. Blue7859. Are there any parametric practices where you need to keep some variables and submit multiple answers? You know, you should, like I said, you should just be doing that as part of your like just kind of like common sense best practices, kind of like fully defining your sketches. You should you should definitely be just kind of working that into your best practices. You know, fully define your sketches and think about how the model is going to change. So in this case, like if I know that the model might get a little bit wider, if I know that I might want to create a version where this dimension here, where this board can, or this thing can facilitate 2 boards up top and 3 boards down below. So currently it can support 1 plank up top and it can support 2 planks down below. But if I wanted to create a version where it could support 2 planks up top and 3 planks down below, then I want to make sure that when I create this hex pattern that I kind of like overfill it and overfill it in a way that when I go to make those changes, it's going to hold up. So before I go in and I have the meeting with the customer, I want to have this ready to go. So in other words, if I'm having the meeting with the customer and the customer says, oh, that looks really good, we also want to sell one that can handle more boards. We want to sell one that can be a little bit wider. Well, I know that I only need to change this one dimension here. So I just need to take this dimension here and add 2.5 to it. So I'll make that one 8 wide and then hit the green check mark, and then everything else updates. That whole hex pattern updates. But the thing is, the only way you're going to know that is if you know what types of questions a customer is likely going to ask. And that's going to be different from one customer to the next. Or if you're designing your own parts, that's going to be different for you. So yes is the answer. Are there any parametric models where you have to change the dimension? Yes is the answer. You should do that with all your models. You should do that with every single model. You should always be thinking, what is the customer going to change? What's most likely the customer going to change? And you should do a little bit of testing on your models to make sure that that's the case. Because it will happen, and it makes you look really good when you're working with a customer or when you're working with your bosses. It makes you look really good if they're like, well, what if I made that wider? And you're like, no problem. I anticipated you asking this question. And so, you should definitely be doing that on all your models. Victor K saying, yeah, this is where variable tables configuration with variables comes in handy. Exactly. That could be another way that you could even just test it. You could just test it and make multiple versions and see if they also rebuild or if they fail. And then if they do fail, you should ask yourself why. So, yep, definitely a great question, and definitely what you should be doing for sure. Matab says, uh-oh. Victor K says, this isn't even his final form. The coffee hasn't kicked in yet. Yeah, it's true. It's true. But we are going a little bit faster today. I'm glad you guys are liking the vibe. All right, let's keep going. Let's keep going with the vibe here. So welcome, everybody. We're going to do a live solve here from the library at TooTallToby.com. If you haven't been to TooTallToby.com before, but you like doing these 2D to 3D CAD challenges, well, you are in luck, because we've got hundreds of these challenges here, and they're not just listed. They are tagged, sorted. You can start out at level 1 and kind of work your way up. If you like this idea of learning by doing, this is a great place to get in your reps, get in your practice. It's kind of like a gym for your CAD brain. And as you guys are going through this library, remember, they're also tagged by the type of model that you're working on. And so that means that you could say, I want to work on 3D printable models, or I want to work on some woodworking projects, or whatever it is that you want to work on. And we add models all the time. And so we've just today been kind of going through and looking at some of the more recently added models. We just added this one earlier today. It's kind of a cool hex pattern. Let's see if anybody solved this one yet. I know this is kind of a newer one, but I wonder if anybody solved it. 6 people have solved this one already. Wow. That is awesome. Who was the first one? It was Barack Stump. Yo, let's go. And look at using Onshape. Then look at this one, CADulation. That's cool. Very nice. Very cool. Well, I don't want to spoil that one for you, so I'll let you guys solve that on your own. But let's do this one here. There was a lot of people who saw this tutorial in SolidWorks, and they wanted to know if I would take a similar approach in Onshape. And the answer is yes, I would take a very similar approach here in Onshape. So let's get into it here, and we're going to begin this challenge in 3, 2, 1, go. And so the question here is, what is the mass of this part in xxx.x grams? And for this part here, I think what I would do is I would create this part here by kind of starting out by looking at it from the front. I would probably create this part using a layout sketch, some kind of a master layout sketch. That's what I did in the SolidWorks tutorial, and that's absolutely what I would do here in Onshape. And so what I mean by that is I would probably start out, following the fundamental rule that I always follow, which is keep your sketches simple. I would probably start out by creating a sketch that looks like this. Just half of the model, kind of coming straight down through here, just half of the model. And that would be it for my first sketch. And I would kind of use that as a master layout to drive all the other features in the sketch. So for example, my second feature, I might take that sketch and use that sketch and extrude it, but then I would show that sketch, and then I would use that sketch to create this kind of offset geometry here. So there's an offset here between these two entities. I would offset that geometry over. I would use that sketch to create this arc here. So I would use that master sketch to create this arc here as well, and then extrude this region here. Again, maybe using that master sketch, or maybe using that offset sketch in coordination. So I really like the idea of keeping your sketches simple. And I think that even when you have a complicated part like this, if you just keep your sketches simple, you can really end up kind of simplifying the overall process. The other thing that I would look at when it comes to a sketch like this is I would look at the idea that you've got a spherical corner coming together with a non-spherical part, like a cylindrical part. It's kind of like a curved part here, but it's kind of like basically it's like a non-cylindrical part. And you have this like cylinder that's running into a sphere, and then you have these sidelines here that are coming down. And whenever you have something like that, a lot of times you can make your life easier by learning how to work with multi-body and using multi-body to facilitate that blend. There's a lot of different scenarios where this comes up, and it's something that we talk about a lot in the multi-body design class, but I really like this tutorial because it gives me a chance to show off how to use that kind of multi-body approach with the idea that at the end, you're going to merge everything together. So that's going to be the approach we use for this one. And I know we took 2 minutes to come up with a game plan for this one, but I think it's always important to come up with a game plan before you jump into your 3D CAD. So if you agree, be sure to hit the like button. Be sure to hit subscribe. We got 69,009 subscribers at the moment. Let's see if we can get that sub count up to 69,420 subscribers before we stop live streaming today. It's a little bit ambitious, but you know, I'm always looking for these ambitious goals. And thank you so much. I see SEH Saray says, love your videos. Thank you, thank you, thank you. And Ate got this one when he was in the tournament. So he did this one live in the tournament. And he says, this one broke my brain. I did it with a loft and that screwed everything up. Yep, that's what can happen when you first get under the pressure and start doing these things. That's why it's nice to kind of be able to take a minute or two and have a game plan. But when you're going up against Ricardo Jean in a tournament, you don't have that luxury. You just got to get in there and go, 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 go. So I'm going to use open in a new window, and I'm going to put this onto my second screen, and let's bring up the timer over here. Let's see if we can beat the average solve time. It looks like the average solve time here is 22 minutes and 9 seconds. So let's see if we can beat that average solve time here using Onshape. So here we go. Let's bring up the keyboard cam and let's create a new model. I am going to create this in the public space. So if you're using a free version of Onshape or if you're using the paid version of Onshape, you can look this up in the public space by searching for T-handle or T-handle 2 or searching for this entire string. So you can just go into Onshape in the free version or in the paid version, then just search the public space for this. And then you can see this entire model and you can look through the entire model history. So now that we're in Onshape here, let's start with our units, workspace units, millimeters, grams, good. Always good to double check that. You don't want to make the whole thing in inches and then realize at the end that it was supposed to be in millimeters. Let's create a construction line here since we know we're going to mirror this. So begin a line here and then Q to turn that into construction. Hit escape, S key line, single click here. We're going to come over. This is going to come over to a distance of 20, which is 1/2 of 40. This is going to come straight up here to a height of 47, which is the distance to the beginning of this arc. We're going to take our mouse and we're going to not click anything, but just come back over this endpoint and then come off of that endpoint with an arc. And that's going to have a radius of 70. We're going to come away from that arc. We're going to come back and touch that endpoint again, then come off of that arc or come off of that endpoint. That takes us into a tangent arc. This one's going to have a radius of 100. And then for this final line here, you probably have to choose to either make it tangent or make it vertical. I usually choose to make it vertical. So vertical line there, come over here to this point, center line, and then come down here to this final point down here. Okay, now we can hit escape. Now we can pick this arc and this line, and then we can press T, which is the shortcut for tangent. T is in Tango, or T is in Toby. And then we can use our S key, and we can create a dimension here that comes from the base of this model up to this line here. This is going to be the center of our cylinder, and that distance is going to be 190 and enter. And once we've got that, the only thing that's left to do is the max width, which is going to be this line here to our construction line. And then we'll cross over that construction line. And then that's going to be 115 and enter. And look at that. A nice all black, fully defined sketch. The little indicator here, the minus sign indicator went away in the tree. That is what we're always looking for. We always want to fully define our sketches. So now that we've got this geometry, we're going to exit that sketch. Could almost rename this sketch here. So Shift N, this could be like the master layout sketch. It's definitely, you know, something that you could consider doing is doing that as like a master layout sketch, just so that you can keep referencing it. And you can also right click on that sketch and you can go here to edit sketch appearance and make that like a red color, something that'll really pop out. So it's easy for you to reference that. So now that we've got that shape, I'm actually going to immediately jump up here to the circular or the cylindrical handle. So I'm going to immediately jump up to this shape here. I'm going to sketch a circle and I'm going to extrude it. And I'm just doing this to give us kind of a reference to this idea of working in multiple bodies. So I'm going to go here, right plane, begin a new sketch, S key, circle, single click this point from our master layout, move over, single click again, let go of our mouse, and that's going to have a diameter of 40. And then I'm going to do S key extrude, and that extrusion is going to go up to vertex, and the vertex is going to be this vertex here. And so we hit the green check mark, and that's like our cylinder handle shape. That's like our cylinder handle shape there. And we're going to kind of leave that up in space, and we're going to show the master layout sketch again. Now we're going to go to the front plane. Now, at this point, we could either use the master layout sketch or we can make an explicit sketch. I kind of tend to ebb and flow. You could go either way. The Onshape guys always get mad at me because they don't want me to create this extra feature that's really not necessary. And it's true, it's not necessary. The only reason you would do this would be if you were maybe anticipating changing the master layout sketch later. Then you might consider making a new sketch here on the front plane. So new sketch, and then maybe like converting these entities manually. So what I mean is we could take all these entities, just the outer entities here, and then we could do manual use or manual project convert type of a command. So that's this command here, use project convert. So one by one, I picked all these, and what that's doing is it's kind of insulating me against the potential of me going in later and like adding a line here on the master layout or adding a line across here on the master layout and having that somehow mess up my outer perimeter shape. This is maybe a little bit too deep of thinking here. You know, it kind of comes into the whole, like, what can we do to make our models parametrically sound or make them able to withstand changes? So it certainly is something that I do on occasion, but it just depends on what I know about the master layout. If I know I'm going to change it a lot later on, I might consider doing something like this. So basically, I just took those outer perimeter sketch entities and traced them into the current sketch, and now I'm going to take that geometry and choose to extrude it. And that's going to get extruded to a depth of 40 millimeters, and it's going to get extruded symmetric. So it's going to get extruded like this. But what I'm going to take care to do is I'm going to take care to make that its own new body or its own new part. So I'm going to click new here, and then that gives me these two parts down here in this parts list. Now, the reason that's important, well, you'll see why this is important in just a moment, but the reason that's important is because it makes it really easy for me to merge these together later on and get that nice smooth blend between the two bodies. So I'm going to choose to make that as a new part, and now you see I've got one part up here, which is the handle, and then one which is the cylindrical handle, and then I've got a different part down here, which is the actual main body of the handle. So, why does that matter? Well, what I'm going to do next here is I'm going to add a fillet. So I'm going to go in here to the fillet command, fillet, and I'm going to add a fillet here to the handle, the main handle shape. So that fillet is going to have a radius of 20. So that's going to leave me with a nice cylinder down here at the bottom. Okay, filleting off this bottom edge here. This thing is extruded to 40. Okay, and so I've got this 20 millimeter fillet. That's pretty nice. But then as we come up through the side of the handle here, those fillets kind of continue up the side of the handle here. Well, once we have that shape, the next thing that we're going to do with that shape is we're going to kind of scallop that shape out. We're going to create a cut that goes down here, and we're going to kind of use that shape to cut this thing away, to cut this thing out. So in order to create that shape, we'll go here to the front plane, S key, begin a new sketch. Let's get normal 2 here. And then let's take this line from the master. This is from the master layout sketch. This line and this line and this line. Let's take these lines here and do a command called offset. So from the sketching commands here, I got my interface a little bit squished here, but here's the sketching commands for offset. Let's take those 3 lines and do an offset. And we're going to offset those 3 lines over to a distance of, offset this over here, to 8 millimeters. Okay, so now we've got that nice offset in place there for those lines, and that's going to set us up to create the rest of the geometry to kind of scallop this thing out in the middle. We're going to create this shape here, kind of come down and scallops out. We'll just create half of it and scallop out that shape there. So we come in here, let's continue to get normal 2. We can create a line that comes over here like so, line that comes down here like so. Got to create a line that comes all the way down to the bottom here like so. And then we could create an arc, and we could just do this with a 3-point arc. So just create a 3-point arc here like so. and that arc is going to have a radius of 14 millimeters. And then what are the conditions for this arc? Well, the center point of this arc should be directly above this point here. So we'll take those two and we'll make them vertical, V, make those two vertical. And then this arc here should be tangent to this arc here. So we'll pick those two and press T, and that makes those two tangent. And so now we've got this nice closed shape here. Whoops, this shouldn't be blue. So grab a blue point, move it around. Whoop, okay, that line's supposed to be horizontal. Pick that line, H, horizontal, there we go. So now we've got this nice enclosed shape here. We can go to extrude, and this is gonna be a remove, and it's gonna be a remove through all. Okay, and we'll make this symmetric. So remove through all, we'll make it symmetric. And let's say we chose this option here, merge with all. Well, that's not really what we want. We don't want that extrude to cut through this part here. We don't want it to cut through the cylinder part, because remember, on the handle of this shovel, that cylinder part should be a full cylinder. So that's why it's nice to have these non-merged, because here in the definition of this part, we could say we only want it to affect certain bodies. Instead of saying merge with all, we could say we only want it to affect this body down here. So now what we're doing is we're cutting away that gray body, but we're leaving that blue body behind, and that is what we want. So we can cut away that gray body, leave that blue body behind, and look at that. That is what we wanted from that handle. And why is that so important? Why is that what we want from the handle? Because look, if we add a fillet here on the handle, look at how smooth that's going to blend in. That's going to give us exactly what we want. Pretty cool, right? Pretty cool. So we'll get into that in just a few more steps, but for now, let's continue working on this model here on this lower section of the model. So what did we create here? We created the main lower shape. We created the fillet on side, main shape. And then we created the, I guess you'd call this like the cutaway main inside shape. All right, so now we can go front plane, begin a sketch. And for this one, I think what I would probably do with this one is I would probably take the sketch that I used in the previous sketch, the sketch that I used for that main cutaway, just pick the whole sketch here out of the tree, and then pick this button here, use project convert. So what that did was, let me hide the master layout. It took all that geometry from this sketch here. It's called sketch 3. It took all the geometry from that sketch 3 and it just traced it right into my current sketch, sketch 4. Sketch 4. So by using that command, that use project convert, this command up here, I'm able to basically trace that previous sketch. And the reason that's nice is because now what I'm going to do, N for normal 2 here, now what I'm going to do is I'm going to create this arc here, which is tangent. So I'm just going to create that arc there, and then I'll have everything I need to fill that in with that kind of like ribbed area down at the bottom there. So it just makes it nice to be able to reuse that sketch in that way. I mean, sure, I could reference the edges of the part too, but sometimes I think sketches are a little bit more robust than edges of the part. They're a little less likely to get filleted, for example, or to get chamfered or cut away or something like that. So sometimes I actually prefer to reference the sketches like we've done here. So I just make an arc there. I don't know what the radius is, so I'll just hit escape. I'll take this point of the arc and this point here and make that vertical like we did before. I'll take this arc and this arc here and I'll make them tangent, as it is called out in the drawing. And then what did I end up with here? I ended up with an inadvertent horizontal. That shouldn't be black. So it should be vertical. It should not be horizontal there. So delete that. Looks like I had a horizontal between this endpoint and this endpoint accidentally. So there we go. Now we can move that up and down. And then the final thing here would be to add a dimension from the plane here to this point here. And that's going to be a dimension of 92. And there we go. Let's go. Let's go. And so now we've got kind of multiple regions here that we could pick from. But what we can do in Onshape is we can just hit escape and then pick this region first. Just kind of click in that region and then S key extrude, and then that'll be the region that gets picked. So this is going to go out to a depth of 6 millimeters and it's going to be symmetric. And there we go. That's the majority of the lower part of that handle. This would be called like the main center rib. And now I think we're ready to start kind of combining things together and working on this top section. So like I mentioned earlier, we would add a fillet in here, and that fillet would have a radius of 20, and it would be applied here on this edge. And now those two parts are kind of starting to line up. And once those two parts are lined up like that, then what we could do is we could take those two parts and we could perform a Boolean. So take those two parts, do a Boolean combine, union here, a union, and merge those two parts together. So now they're all just one single part, all one single body. Now, why is that important? Because now we're going to try to add in the fillet here along this edge. So we go here to the fillet command, fillet, and we're going to fillet here along this edge. And what is the radius of that fillet going to be? It's going to be a radius of 12 millimeters. And that brings you right up here, right to this location. So you end up with this kind of like smooth tangency going across there as you add in that fillet all the way around. So we fillet that off at 12 millimeters. We hit the green check mark and boom, there is the fillet between those two. And so now for this upper region of the handle, what we need to do, so maybe I'll call this one fillet upper corner. And then this one will be called fillet blend handle, I'll call this one blend lower to handle. I know the whole thing is a handle, but I kind of think of this as like the lower region. And so then what we do is we just add in our cuts before we mirror everything. So for the cuts up top here, what we see is that we've got a distance dimension here of 6 total. So 6 total here from the customer. So a lot of times if I have a cut like this, that's like 6 total here, it's really saying that this wall is 6, but sometimes you can kind of get away with making a cut that represents the wall thickness as well. And what I mean by that is I could pick this face here, begin a sketch, S key, begin a circle, put the circle right here at the center of this arc, and then give that circle a diameter of whatever the smaller hole is, 15. Enter. And so now I can take that circle and I can do an extrude cut. So extrude, remove, symmetric. So now it's going to go off halfway in this direction and halfway in this direction. And then I can make that symmetric depth 6. Enter, enter. And the nice thing about that is that then when the customer is looking at this and the customer says, well, what's the depth? You know, what's the wall thickness of that rib? Once I have the whole thing mirrored, I could go here. I could call this one Shift N. I call this like cut, smaller hole, and wall thickness. Something like that. Like I could put a note in for myself so I would know what that is. And then when I'm talking to the customer, I could say, oh, it's 6 millimeters. And they could say, oh, could you change that to 8 millimeters? Well, if I wanted to change the wall thickness in that area, I would just change the depth of that hole. Because the next hole that I'm going to create is going to be here, this face, S key, begin a sketch. And then I'm going to create a center point circle. And the center point circle here is going to go on this location right at the center. And that center point circle is going to have a diameter of 28. And then that one is going to go through everything. So extrude, remove, through all. And now we've got that wall, wall thickness, which is from this wall to this wall based on this cut extrude that we created, the cut that we created here, the cut smaller hole and wall thickness. So it's just kind of a different way of thinking about that, but it's good to think about these things in a lot of different ways. Serial Sal is saying, so that command is almost like copy and paste in the current sketch. I'll do a review of that command at the end, Serial Sal. Not exactly. It's more like a trace or like a projection. Not exactly like a copy and paste, though. In this case, it is because they're coplanar, but it's not always like that. Yeah, good question. I'll review that use project at the end of the tutorial. So this one would be a larger hole in handle. There we go. And now that we've got that larger hole in handle, now we're ready to make the final couple of features down here at the bottom. So this face here, S key, begin a sketch, S key, circle, single click, move our mouse, single click, type in the diameter of that circle, 30, enter, S key, extrude cut, remove, depth is going to be 40, enter, enter, and then front plane, S key, begin to sketch, N key to get normal to, S key, line, single click, move your mouse up, single click again. That's going to be 12, enter, move your mouse up again here, single click, 18, enter. And in Onshape, you don't have to convert those to construction. It's just, it knows that that's not a valid perimeter to create a closed region. So you can actually just leave those open. So make that one 6, make this one anything, pick this one, press E for equal. Whoops. Pick this one, press E for equal. Try this one more time. This one, E for equal. think I kept hitting the wrong key there. And then S key extrude, and then you see it realizes that those are the most logical closed regions. So we would do remove, through all, symmetric, and then that punches those holes through. Okay, so then this would be Shift N, larger hole at bottom for shaft, and then this would be smaller screw holes at bottom. And finally, we're going to mirror this thing. So we pick this face here, go into our patterns, choose mirror, and we're going to mirror this, sorry, pick the plane, mirror this. Okay, and merge that together. And then we're going to right click here and we're going to say assign material. This material is going to come from the TooTallToby custom materials library, and it's going to be the TooTallToby ABS. Hit the check mark, come down here, pick this button, and that is going to allow us to measure the mass of this part. And we're coming up with 166.3. So if we move the app back in here, 166.3 and enter, and oh yeah, we did it. Let's go, let's go. 22 minutes and 15 seconds. So we were slightly slower than the average time, but we did get it, and we did get it correct on the first try, and that is what is important. Okay, it's good to be fast. It's really good to be fast, but you're never going to be slower, or almost certainly never going to be slower than it takes for you to send the parts out and find out that they are wrong. So if you need to take a few extra minutes or even a few extra hours to make sure you got it correct, it's still going to be better than sending out the drawings and having them be wrong and then getting the wrong parts made. So always take your time, always try to get it correct. But the more you practice going through these workflows, the more you practice, getting it wrong and then finding what you got wrong, the less likely you'll be to get it wrong, the more likely you'll be to get it correct on the first try. So we'll submit that one, and let's go. We get another model complete in our total record. Let's see, how many are there total? There's 322 total, and I've done 96, the opposite of 69. We're trying to get to 69 420 subs today. I don't think we're going to quite get there. But guys, if there are any specific ones you want to see, let me know. Let me know. Otherwise, I'm just going to keep on going through. Matab says 241207. Excellent. I like it. I like it. Thank you. And yeah, Benjamin says slow and steady. Exactly. Walking. John says walking. Exactly. Yes. Slow and steady is indeed the key. So, as far as that convert command works, the difference between the copy and paste of a sketch and a convert is that the convert does maintain a parametric relationship to the original geometry. So if, for example, I go here to a new document and I say convert example, this is like the most common example. And then I go front plane, begin a sketch, and create I'm shooting from the hip here a little bit, so kind of bear with me. But let's just say I create like a base here. So 110 by 30, and then I go extrude, and I say that's going to extrude out to 170. And then on this end, I create kind of a smaller region. So we'll go like go 80 by 125. It's good. And then it's vertical. And then we'll include a hole in that sketch. Okay, so we'll include a hole here, 20 millimeter diameter hole here. Okay, and then we will extrude. And then let's say we reverse direction on that, like so. So now down here at this end, we want to line up with that hole. So we could begin a sketch here, and then we could create some geometry that we want to align to that hole. So we could do like a tombstone shape here, like so. And then what we could do is we could take this arc here and we could use that project convert. Now you can do it with an individual arc, or you could do it with an entire sketch. But in this case, I'm just going to take that individual arc and I'm going to do a project convert. And so you see what that did was it took that and it projected it forward. But if I just did a copy and paste, there wouldn't be a dynamic link between the two. So what I mean by that is if I take this point here and hook it to the center of that arc, and then if I take this dimension from that original arc to this arc out here, and I say I need there to be 5 millimeter worth of meat there. Now I could do feature extrude, and I could reverse direction on this one as well. make that one a little bit thinner. And then I could go back to the earlier sketch here, and I can take the earlier sketch and change it. So this could maybe go from 20 to 25. Well, that's going to push downstream, and this is going to update, and this is going to be 25 now as well. So that diameter is 25 as well, so it projected forward. Or if I go to the earlier sketch and I relocate it, so if I realize like, oh, I was supposed to have a dimension here. Why did I forget to put a dimension here from the base up to there? That's supposed to be 75 millimeters. You know, then this is going to update as well because it's projected through. It's not just copy and pasted. So basically what I did was I took, you know, instead of just taking that one circle, what I did was I said, I'm going to begin a new sketch here, and then I'm going to go back to this sketch here, sketch 2, and then convert. So that kind of took the entire sketch and pushed it through, and it projected it through. So I get it. So it changes the projection if changes are made. Yep, exactly. So what I did this time was I took that whole thing and I projected it forward, and now I'm going to take that area, and I'm just going to make that one a little bit less thick going out the other side. So that could be an application for something like that. And then again, if I go back to the original and I change the original here, this is going to now become 155, and this is going to become a little bit more narrow. It becomes 60, and then I hit the green check mark. Now the projected version also updates. So that's the main difference. You could also take this sketch here and you could right click on this sketch and say copy sketch. There's a copy sketch here in this menu, and then you could come over here to a different sketch plane and you could right click and you could do paste sketch, and that certainly works, but there's no relationship between those two. If I go into this sketch, actually it didn't even bring in the dimensions from this one. So there's no relationship between those two, where with the projected, you know, use convert project, there is a relationship. And sometimes you'll even do it when they are coplanar, like in the example of the master model, you'll do it if they are coplanar as well. All right, so we got a request here from a tab. He says, how about 24-12-07? Let's go. So we'll go in here to the practice models library, take a look at the 2024 library, 2024, and then we can sort this by the newest first. So 2024-12-07. Let's see what we're getting ourselves into here. All right, it looks like CrispyCo already has a tutorial on this in SolidWorks, so maybe I'll do this one in Onshape as well, and that way we'll have some variety here on these. All right, guys, if you guys want to do this along with me, you are welcome to. I'll give you a view of this thing, kind of big screen, so that if you want to do this along with, you can give it a try as well. So here we go. This CAD challenge and tutorial begins in 3, 2, 1. Go. And so we see here the question is, what is the mass of this part? Let me see if I can make this full screen. I don't have the full screen window on there. Let me do open in a new window, and we'll make it as full screen as we can for you guys in case you want to try it from home. Try it along with me. Oh yeah, I remember this one. This is a good one. Yeah, so this is kind of a weird part, right? It looks like it's a sheet metal part, and in the real world, it probably would be made as sheet metal. But the thing is, whenever you bend in sheet metal, you need to have material to bend. And so when you have a shape like this that's bent up and over like this, you're really doing like almost like a coining type of operation. You're deforming this on some type of a die just in that region, and you would definitely need some kind of relief here unless the material was super thin to accomplish something like this. So this looks like it's like a shut-off lever. It looks like for some kind of like a plumbing or a water system. Very, very interesting part. We would probably choose to model this not as sheet metal, but model it as solids using some thin wall solid type of stuff. And we would probably choose, let's see here, for the origin, we would probably choose this location here as the origin. This is another part where I would definitely be tempted to create this as using a layout sketch, create some kind of a layout sketch looking down from the top. And the reason for that is because we have so much information that's coming just from this location. It's clearly all being defined on the top. So this is one that I think I'll probably, again, create using a layout sketch looking down from the top, similar to the last example, and then kind of work my way out from that layout sketch. I think that what's going to be tricky about this part is going to be creating this geometry over here. It's kind of interesting. The walls on this geometry over here look like they're straight, and in the real world, they wouldn't be. You would kind of be bending this part, but you know, maybe this is a plastic part that was built for a a children's toy set that is used to teach children about plumbing. Maybe it's something like that. So it's like a plastic part so we can get away with those straight walls. But in the real world, this would almost certainly be some type of a sheet metal part. You'd stamp it out, and then that means that these walls here would be perpendicular to the wall thickness. But we're going to try and make it match the drawing exactly here. It looks like this is a part in inches, and it's using fractions. And we're going all the way down to 16ths for fractions here. So we get some practice using fractions in Onshape as well. So 2.5 minutes there to come up with a game plan, I know, but I think it's always good to come up with a game plan before you jump into your 3D CAD. Let's give this thing a try and see if we can't get this thing modeled up in 3D CAD with the correct mass. So here we go. We're going to create a new document here. I'll call this one 24-12-07 space shut off, so that if you want to look this up in the public space, you can. So you create a new document here. We'll bring up our keyboard cam. We're going to try and beat the average solve time here of 17 minutes and 5 seconds. And we're going to start by going in here. Whoops. We're going to start by going in here to the hamburger menu up at the top here. And from the hamburger menu, we're going to say workspace units and change this to inches and change this to pounds so we can answer it in the correct units here. And then top plane, S key, begin to sketch, N key to get normal to. And let's create that layout geometry. I'm going to start out here with those circles. So this is 2.625 for the OD, and this is 1 5/8 for the ID. So I think you can do 1 plus 5/8 in Onshape. Yeah, and then have it do the equation for you. So you just type plus between the number and the fraction. Now, like I mentioned at the start of this tutorial, this is one that I would almost certainly do with layout geometry. So that means that I would create a shape that looks something like this. And then I would add the dimensions to that shape because of how it's defined here. So like this distance to the max tangency point is defined looking down from the top. And it's defined as 5 inches. And then this radius here is 1/2. 1/2. And then this distance from the center point, or from this plane to this edge of the part, is also 1/2, 1/2 inch. So I'm going to define all that here looking down from the top. And then on the back end of this thing, I'm going to take the same strategy. So I'm going to create some geometry that comes over, down, and back over here. And this is how I approach my sketching. You don't have to sketch every single thing that's on the sketch at once. A lot of times I'll just make like 1 or 2 arcs, and then I'll define them, get them fully locked down, and then I'll go on and make the rest of the geometry. And that's a great way to not get your sketch all out of proportion, and also not end up with like the sketch kind of becoming tangled in on itself. So it looks like this distance from here to here is 2 3/4. If you can't do that math, you can do 2 plus 3/4, and then let Onshape do the math for you. And then the distance from here to here is also 3/4. Nice fully defined sketch there. Now, as far as that kind of bend region goes, I think I'll probably tackle that as a separate sketch. I'll probably get into this region here, looking in from the end, and kind of like try to figure out what needs to be cut away to get that shape the way that I need it. So I'll probably come back to that as a separate sketch. I think I've got enough in there for the first sketch. So we'll take that geometry and we'll start extruding some areas of that geometry. I guess the other thing that's kind of important to me here is the distance where this bend begins. This bend right here, that distance where that bend begins is going to be important, because that means that, if I can kind of get close to that area, then I can basically just extrude all of this as a thin feature and then go in and create that little formed area on the end. So I think that's what I'm going to do. I think I'm going to just figure out where that bend is supposed to be and include that in this sketch as well. So I'll create a line here where that bend should be, and then I'll add in my dimension. So the dimension is, let's see, there's a dimension to the flange location, which is 4 plus 5/8. And then there's a dimension back in this direction to where the geometry ends, the flat geometry ends, and that distance is 3/16. So I'll just include that here, 3/16 to that area there. And so now I can take that geometry and do an extrude, and I don't need to extrude the entire sketch. I could just extrude this region, and this region, and that geometry is going to get extruded up to 3/16. So let Onshape do the math for me there. So I would consider that kind of like the first main flat shape, you know, and I'd probably call it something like that, like main flat shape. And when it comes to creating your models, this is the habit you want to get into. You want to kind of discretize your models into different features, into different areas of the model. So that's one area of the model. Another area of the model is going to be the cutout for the formed shape. Another area of the model is going to be the formed shape. And then another area of the model is going to be this shape up here, where it kind of comes up and it bends down at an angle. And then you've got that angled tab that's sticking out there for that shutoff. So each one of those is a different area of the model. We're done with the first area. Let's see if we can now get on to that second area. So it looks like in that second area, see, I'm just trying to see if there's anything in here that's going to help me kind of understand what this is without drawing it. I feel like I almost have to draw this up. So we've got this radius here of 1/16 on the inside, up and over and down, and then a radius here of 1/16 on the outside, and then a radius of 1/4 on the inside, up and over, and then back down that radius of 1/4 on the outside. So if we take that 1/16 plus 3/16, which is the wall thickness, then that gives us 4/16, which is 1/4 inch, and that is this radius right here. So I'm thinking I could just draw this whole shape here and then do an offset entities, and then that should give me the perfect geometry that I need to kind of locate where that cut needs to be. So I'll kind of like do this in an interesting order here. I'll create this sketch here on the end. So this sketch here, begin a sketch here, and I'll create kind of this sketch. Come back, touch this end point here. That's going to be my 1/16 radius. Okay, and then we'll take this point and make those vertical. And that way, when I take this point and make it coincident here, it will also be tangent. So if this point is vertical to this point, then that means that this arc is going to have a tangent transition into this edge here if I make it coincident. So I made those vertical, V, make those vertical. And now I can continue that sketch. So I'll create another line here, come off of this endpoint here, come back to the endpoint, touch the endpoint, come up and over. So that outside radius is going to be 7/16. And then come down here, come away, touch the endpoint, and then come off of that. That's going to have a radius of 1/16. Hit escape. Take this point and this point, make those vertical, V. Take this point and this edge here, make those coincident, I. And that way I've got that nice smooth transition into that surface. And it looks like the center of that arc is also centered with the rest of the model here. So the center of that arc is this center line here, which is centered with the rest of the model. So I can just line that right up with the origin. This is why it's good to really think about your origin before you get started. So we can make these guys here vertical, V for vertical. And then it looks like the max height to that arc up top there, the distance from here to here, the max height of that is 13/16. Okay, 13/16 to that max height there. So now, at this point, what I could do is I could just exit that sketch and I'll come back and I'll use that sketch a little later. But then what I could do is I could take this face here, begin a sketch on this face here, and I could create a sketch of a rectangle that starts here at this point and comes out like so. And then I could hit escape and take this point and make those coincident as well. So I'm using this geometry that I just created to act almost like a layout sketch to lay out this rectangle here, which I'm going to use to cut away the geometry that I'm going to fill in with this sketch. So that cutaway shape is going to be to a depth of 7/8. So we'll drop this in here, 7/8. And now we could do extrude, remove the roux. And now we can go back to that earlier sketch, this sketch here, and we can do extrude. And this is going to be a thin feature extrude. See, I could offset that geometry, but I could also just do thin feature extrude here with that sketch. So that thin feature is going to have a thickness of 3/16, and it's going to go to the other side. And then where is that going to go? It's going to go up to vertex. So for the depth of this, it's going to go up to vertex, and that's going to go up to this vertex here. We're going to do an add so that it merges in, and there we go. Now we got that kind of formed shape on the end of that part, on the edge of that part. So this would be Shift N, cut away for formed arc shape. And then this one here would be formed arc shape. All right, making some pretty good time here. So we're down to kind of the final area, the final discretized area of this model. So now that we've got this final area, how are we gonna solve this final area here? Well, this one is definitely interesting. Maybe see, this distance here, this 4 5/8 is too. Let's see here. It's to the tangency that we're seeing. Man, this is a rough drawing. What is that too? It's 4. Oh, I see. It's 4 5/8 to this wall. Okay, and so then we're calling out the 316. This is one of my earlier drawings, guys. So this is one that's we've learned a lot. We've learned a lot over the years. So, okay, so. Serial Sal in the chat says, "If the thin feature is something I rarely see, and its usefulness is more and more." That's awesome. That's awesome. And Chris says, "This is mesmerizing to watch, but so easy when you know how." Yeah, awesome. Glad to hear it. Okay, cool. So that means that this dimension here that I extruded to is right here to this inside wall. That's great. That's actually perfect for what we're trying to do. So now we basically need to extrude this shape looking in from the end that comes up, comes down, and then comes back over here. We need to figure out what that shape is, and we need to extrude that directly off of that other end shape. So we can kind of see what that shape is from this view here. It goes up to a max height of 7/8, and then it comes down at an angle of 15. That's all we really need. If we have that, then we should be on the home stretch with this thing. So let's give it a try and see what happens here. So we go to this surface here and begin a sketch, and then we're going to create a sketch here that starts on this line, comes over here to this corner, comes up, and this is going to come up to that height of 7/8, 7/8, 7/8. Then it's going to come down at that 15 degrees, and then it's going to close back off here, back down to the bottom. So if we create this dimension on, whoops, not that dimension, we already have that one. If we create a dimension on here from this line to this line, and then we make that dimension 15, that gives us a nice fully defined sketch. Now we can do S key extrude, and then that's going to extrude to our depth here. This will be a solid extrusion. So you pick solid here and then pick the sketch again. That's going to be a solid extrusion, and that's going to go out to a depth here of 3/16. And now we should be able to create the final geometry, which is going to come out to that total depth of 5 inches. Now, something kind of cool that you could do here is you could go back to this main sketch, and we've got this distance dimension that we created here. We kind of laid things out here. Whoops, make that from the top. We kind of laid things out here from the top with this distance sketch. But what we could do is we could create a line here, either a solid line or a construction line, and then we could take this line here. I picked up on a horizontal there by accident. We could take this line here. Let's make this line vertical, and then let's make this line construction. And we could take this line here and make it tangent to this arc here. Now, why does that help us? Well, it helps us because now we have a point here that we could go up to when we're defining the depth of this next extrusion. So here what we did was we started out with a layout sketch. Now we're going back into the layout sketch retroactively, and we're adding in some additional geometry to help us. Now, we also could have done it with a line here, or we could have even done it with just a point here. But a lot of times I like to draw a line there because it just helps me remember, you know, that I did have a piece of reference geometry there when I'm looking at the layout sketch. So for example, if I showed that layout sketch and then I did a right click and said edit sketch appearance and made that like a red color to make it stand out. Well, now I know that there's a point here that I can reference, or a point here that I can reference. And when am I going to reference that? I'm going to reference that, and this is one of the things I love about Onshape. I'm going to reference that when I grab just this edge here, just going to grab this edge, and I'm going to do an extrude. And let's go here to thin, and let's pick that edge again. Oh, can I not pick that edge? Oh, I can't just pick that edge, huh, for my, oh, okay, I do need to have a sketch line. Ah, rats. Thought I would be able just to pick that edge there. All right, no problem. Let's do it. Let's make a sketch here. Or actually, you know what? Wait a second. You know what we can do? We could just show this sketch. Here we go. We can just show this sketch, right? And then we could do extrude thin, and then we could pick this line here from that sketch. Oh yeah, that's what we like. Let's go Onshape. That's what we like. And so that extrude there is going to be to a depth of, or to a thickness, excuse me, of 3/16, so 3/16 for that depth, and then we'll reverse the direction of that, and then that thing is going to go out to a depth of up to vertex, and it's going to go up to this point here. Now, the only problem with this is that now we're ending up with this result here. We've got, it's nice that we're using thin feature. I like using thin feature, but I don't know if that's actually what we want because we end up with this result here. So let's see how this looks. Let's see what we can get away with delete face, and then if we can't get away with it with delete face, then we'll just do it. We'll do it with a solid extrusion. So let's see what happens if we do delete face here. So if you search here for delete and you look up delete face, it's an amazing tool. So delete, and we do delete face here. And then if we just get rid of this, can we delete and heal down to this face here? Probably not, right? Now we're getting a warning here. Yeah, probably not right up to that face. So we could do it on this side. I'm pretty sure we could do it on this side. So delete face. Delete and heal, yeah? No, okay, you can't do it on either side, okay. Okay, all right, that's all right. I was kind of worried. I should have thought about that. I didn't really think ahead when I did that thin feature extrude. So instead of doing that as a thin feature extrude, what could we do? I mean, we could still reuse this sketch, right? We could go back here and we could create another line. And then we could say that this line is parallel. So this line and this line are B for parallel. And then we could create a dimension between those. Let's see if this over-defines a sketch like what we talked about earlier in the live stream. So 3/16. Yeah, we can do that. It's no problem, right? I wonder if it would over-define it if I made that line 15. Let's see. Instead of making this parallel, this is kind of a callback here to something we talked about earlier in the sketch. Parallel. I think it's because capital B. I think it's because a capital B has the parallel lines in it. I think Onshape does make an effort to like help you remember. Like perpendicular is L, and I think it's because that's what that shape looks like. And parallel is B because the like two lines of the B are parallel. At least that's how I remember it. Okay, so anyhow, so now let's see if I add a dimension between these two, between this line and this line, does that go over defined? It does. Interesting. Very interesting. It does go over defined. Okay, so when you do it with a parallel relationship, it doesn't, but when you do it with an explicit angle dimension, it does. That's really interesting. Okay, well, we did talk about that a lot earlier, and we talked about the idea that it's because when you have a dimension between two lines, you're kind of like imposing a parallel relationship with that linear dimension between two lines. So that's interesting. Not surprising, but it is interesting. So now if we exit that sketch, now we've given ourselves a region here that we can extrude as a solid. So we can do extrude solid this region, and then that extrude is going to go up to vertex, and that vertex is going to be this vertex here. Okay, and we hit the green check mark. Then this is the one area of this model that gets a little bit sketchy because it just calls it out as a full round, right? Oh no, it does call it out as 2 1/2-inch. Okay, because these 1/2-inch fillets are probably not going to match up very well. They're not going to match up perfectly. So if we did then here S key fillet, and then we make this 0.5 or 1/2-inch, then we're going to go from this edge and go from this edge, and Onshape does blend them together into one face. That's kind of cool. So it does match them up. Yeah, no problem. No problem. I guess because we're looking down on it from the top, maybe that helps. I don't know. All right. And let's see. Are we done? Did we get it all? We got these fillets in the back here. We got these down here. We got this. We got this. Did we miss any fillets on this bend? Yeah, we did miss the fillets here on this bend. So the final thing we need to do is add in these 1/16, 1/16, 1/4, and 1/4 fillets. And you want to remember in Onshape, the shortcut that you use for the repeat previous command is you hold shift and then you press enter as you are jumping into the next command. So the inside fillets, S key fillet, the inside fillets here are 1/16, this edge here and this edge here. And then you hold shift and press enter. and that adds those fillets, but takes you right back into the fillet command. And so the outside ones are 1/4. And so for that outside one, it would be this one and this one. And then once we add in those, we hit the check mark. And I think this part is looking pretty good. We could press P to hide our planes. We could maybe do some final renaming here. So this one would be the vertical wall to angled handle. And then this one would be called angled handle. And then the other thing we'd want to do here is right mouse button on the name of the part, go to assign material. This is going to come from the TooTallToby custom library of materials, and it's going to be 6061 aluminum or 1060 aluminum, an older material from an older challenge. And then I also like to right mouse button here and just say edit appearance and change the appearance. I think the customers always like it when you do this, make it kind of look like their part. It also helps you when you're looking at it in an assembly. And so now we can click here, display mass and section properties, and we click on the part, and we're coming up with a mass of 0.191 pounds. And let's go back into the app and see if we got it correct. 0.191, and enter, and yes, we did it. Yo, let's go. 1 for 1 all day. That's what I like to see. So that is your tutorial for that 24-12-07. Thank you so much, Matab, for asking about that. That is awesome. Thank you, thank you, thank you. And the CAD Queen is back in the chat. Welcome back. Welcome back. We see Kate is back here in the chat. Hello, hello, and welcome back. Awesome. Thank you, thank you, thank you. Glad that workflow works good. I guess the ambiguity is it might look like the dimension on the vertices instead of the parallel lines. Yeah. Yeah, that's true. Yep. Parallel, yeah, exactly. Awesome. All right, we submit that one. And that is another one that we have solved. We now solved 97 out of 322. So, guys, I think that's going to be where we're going to stop. I don't think we're going to make it to 69,420 today, unfortunately. But I think that's going to be where we're going to stop for that one. I'll mix some of those out and make them into tutorials. If you like these kinds of sessions, we could definitely do some more of these sessions. It's always great to see everybody in here. I really do appreciate all the suggestions. And so maybe if we do more like this in the future, you guys could give me some more suggestions. And I just want to say, as always, thank you guys so much for joining me. It's always so fun to go through this. It'll take some time. Let's see. Victor K says, for keyboard shortcuts, I think I'm going to switch to Aaron C's method of all shortcuts on the left hand. Yeah, I really like that one too. Yeah, that's a great suggestion. I like that. I like that. Seb says, I arrive and we leave. All have a nice day. Thank you, thank you, thank you. Thank you for all your tutorials. Starting to learn a new hobby in my 50s. That's awesome, Chris. Oh, guys, one thing I didn't really officially announce here. I guess I'll kind of like soft. We'll call this like a soft launch here. At cadpractice.com. We can set up classes, and you would set up a class if you were an educator. You would set up a classroom, and then you would do that to like have students join you in the classroom. But we could also set up a classroom to use as like a club. Like you might use it as a robotics club or something like that. But I'm thinking we're going to set up a classroom as like a TooTallToby club. It could be kind of like the Model Monday Live crew, the live stream crew, whatever, you know, the TooTallToby club. So I'll reach out to you guys and I'll start inviting you guys into this, or you can reach out to me on Discord, reach out to me here on Model Monday Live, whatever. But maybe we'll start working this into Model Monday Live a little bit more as well. Regardless, it'll be great to get feedback from you guys who've been with TooTallToby for a long time on how to use this. And I'll just set up the club and then invite you guys into it at some point in the near future. So be on the lookout for that as well. And keep in mind that if you do have a club, if you are at a school or have a robotics club or anything like that, that can also help you organize that and set up leaderboards just for your club. You can do that with cadpractice.com. So guys, awesome live stream. It was a lot of fun. Congratulations to our winner, Matab, winning both points today. Great job. Great job. Says 20 plus subs for the stream. Not bad. Hey, I'll take it. I'll take it. Happy to collect those subs. Don't forget this Friday we have our semifinals. So we're going to see Matab and T-Lus, and we're going to see Neil Z, and we're going to see John Moriarty competing to see who gets through to the finals of that tournament. Guys, we did get some really nice printers for that tournament from Bamboo Labs with the AMS system, with the material switcher. So very excited to have those prizes for all of the competitors. So be sure to join us on Friday for the Autodesk Speed Modeling Tournament. And it's gonna be awesome having all those runners in there. And thank you, Dark Luna. Dark Luna says 69 subs is crazy big. Yeah, we officially crossed over 69 subs. I'm here fidgeting with this toy as we are talking. Yeah, we're officially past 69,000 subs. So a big day for sure on this 420. 69,420 subs. Or 420, 69,000 subs. I'll take it either way. We're going to do a giveaway on Friday. Yeah, thank you, Vicky. That's a great point. We are going to be doing a giveaway of one of those printers for the Fusion tournament on Friday to the chat. So everybody who tunes in on Friday, you're going to win. Not everybody's going to win. Everybody who tunes in on Friday is eligible to win a free printer just for being in the chat. Everybody except for the final 4 runners. The final 4 runners are not going to be eligible to win the free printer. They're going to be in the running to win a printer of their own by competing. But everybody else in the chat is going to be eligible to win a printer. So be sure to join us on Friday for the live stream for the tournament. It's going to be awesome. If you see any posts about this tournament, be sure to give those posts some love. That really helps us as well. And Jim Hughes says, have the best week of all. See you all Friday. Thank you all so much for sticking with me. This was a very long stream, but it's always such a fun way to start the week. So thank you guys. I really appreciate all of you being here with me in the chat. I'm not sure why that other chat doesn't update correctly. I got to try and fix that, but I'll fix it at some point. But guys, thank you all so much. What a fun way to start the day. What a fun way to start the week. And I look forward to seeing everybody throughout the week in Discord. And I look forward to seeing everybody live on Friday. And if you don't make it on Friday, that's okay. I will see you on the next episode of Model Monday Live. See you, everybody.